There's no way. There's no way. There's no way. I'm gonna lose my mind. Woo! Bro. Day 9. Disk defragmenter. Oh, this will be fun. A disk defragmenter. Okay, cool. Another push of the button leaves you in the familiar hallway of some friendly amphipods. Good thing you each somehow got your own personal mini submarine. Hey, good thing. The historians jet away in search of the chief, mostly by driving directly into walls. Alrighty, we're a paragraph in, this is wild. While the historians quickly figure out how to pilot these things, you notice an amphipod in the corner struggling with his computer. He's trying to make more contiguous free space by compacting all of the files, but his program isn't working. You offer to help. Oh my god, we're going to defragment. Alright, welcome to the Windows 3.1 and Windows 95 days. Let's do this. He shows you the disk map, your puzzle input. He's already generated. For example, and then it's just a string of numbers next to each other. The disk map uses a dense format to represent the layout of files and free space on the disk, so files and free space. The digits alternate between indicating the length of a file and the length of free space. Oh, that's interesting. So a disk map like 1, 2, 3, 4, 5 would represent a 1-block file. Okay, so that's the one. 1 file, 2 blocks of free space, 3-block file, 4 blocks of free space, 5-block file. Okay, that makes sense. A disk map of 909090, that would be 9 files with no free space between them. Okay, cool. That's exactly what it is. 9 block files in a row with no free space between them. Okay, this makes sense so far. Each file on the disk also has an ID number. Oh boy. Based on the order of the files as they appear before they are rearranged. Oh, we're going to rearrange them, I see. Starting with ID 0. So the disk map 1, 2, 3, 4, 5 has 3 files. A 1-block ID with ID 0, a 3-block ID with ID 1, and a 5-block ID with ID 2. Okay, so just like an index of the arrays of files. Okay, got it. Using 1 character for each block where digits are the file ID and dot is free space, the disk map 1, 2, 3, 4, 5 represents these individual blocks. Okay, right, there's oh, we're going to use their ID. Okay, yeah, so the ID 0 shows up 1, and then we have 2 free spaces, so 2 dots. The ID of 1, which is 3, shows up 3 times. Okay. So we just expand that compacted format. We decompact that format. So the first example above, represents these blocks. Okay, so block 0 shows up twice. Then we have 3 dots. And then block 1 shows up 3 times. Okay, this format's actually really, really simple. Okay, I like this. It looks complex to the reader, but like storing this in like code is gonna be easy, famous last words. The amphipod would like to move file blocks one at a time from the end of the disk to the leftmost free space block until there are no gaps remaining between free file blocks. Okay, so this is the defrag part. For the disk map 1, 2, 3, 4, 5, the process looks like this. Okay, we expand 1, 2, 3, 4, 5. We grab this thing that was at the rightmost block and we move it here. We grab this thing and move it here. Okay, so we grab something from the right and move it as far to the left as we possibly go until we are left with nothing but data or free space. We need to have all data on the left, all free space on the right, no interweaving. So all the data has to be contiguous at the end of this. Okay. So this example, yeah, oh wow, this is cool visualizing it. You just take this last number here and you move it as far left as it could possibly go and you generate this. The final step of the file compacting process is to update the file system checksum. Is the checksum the thing that was above? Like the thing that we were... Well, let's see. To calculate the checksum, add up the result of multiplying each of the block's position with the file ID number it contains. The leftmost block is in position 0. If a block contains free space, skip it instead. Don't quite understand this paragraph, but we're going to keep reading and see if anything kind of makes it clear. Continuing the first example. Okay. And this is the first example. That's the name of it. The first few blocks positions multiplied by its file ID number are 0 times 0 equals 0. So we have 0 here. 1 times 0 equals 0. 2 times 9. 3 times... Okay, so this is the position it shows up in there. And then we just multiply it by what number appeared there. Oh, okay. So we literally just go through this character by character and multiply its index times the number that's there. That's sort of a way of proving we got it right, which is perfect. I mean, yeah, call it a checksum. Yeah, hey, that makes sense. Compact the amphipod's hard drive using this process requested. What is the resulting file system checksum? Be careful, copy and paste the input puzzle. It is a single very long line. Okay. Hold on. In this example, the sum of these is 1928. Yeah, and that's just the sum. A single very long line? The sum's going to be a very long line? I mean, aren't we going to be limited by like a, what, 64-bit integer probably? I don't know. I guess we'll see. We'll see. Greetings from Germany. I like your content. Yo, appreciate it. Thank you. Welcome. Yeah, hope you enjoy the stream. Okay, if I understand this correctly, it's not so crazy. We have this format. We have to turn this format into this format. Okay, so we have to go through and decompress. We'll call it decompress. We decompress it, and then we defrag it. I guess what should we call it? We should come up with names for these processes. First thing we do is we decompress it, then we defragment it. So we push everything to the left and everything to the right, and then we calculate checksums. Okay, so if we do this puzzle correctly, there's only 3 things we have to really do. Decompress, defrag, checksum. That should be it. So yeah, I guess let's go ahead and get started here. All right, so we have day 0 through 8. Let's go ahead and make day 9, and we will, I guess, get some input here. So we'll use the example that they gave us. So here's the example. We'll call it example input. I'm just copying this from the website. Let's do this. So we have our example input. Now we need to get the real input. So what we have now is we just have these 2 files. We have our example input and we have the real input. Yeah, let's shrink this down a little bit so I can see it better. Cool. Let's see. So in our example input, actually, how many lines do we have? I think they both should have 1 line, right? Yeah. In our example input, let's just do both of this. Start out text. So we have 20 characters in the example input, and we have 20,000 characters in the real input. Technically -1. There's a new line at the end of these files. But that is so fun. So I mean, our algorithm better work here. So let's go ahead and do this. So let's go ahead and make part 1. And this will be our first script, and this script is going to do 3 things. Read the data. Let's just write down what we have to do. Read the data, decompress the data, defrag the data, generate checksum. Cool. So that's it. That's all we really have to do here. As long as we implement these 4 things, then we can get the answer. So let's go ahead and read the data first. We know it's just 1 line of data, which is super nice. So we can just read the entire thing. Actually, we can just read the entire thing into an array. Let's call it compressed. So this is the read built in. We give it -r so it doesn't do any backslash mangling. It shouldn't matter here. It should just be numbers. A to read it into an array, and then this is the variable name we're storing it in. We don't need to give it any sort of thing to read from because it'll read from standard in by default. And now if this works, we should have an array of all of the numbers that have been read. So we can prove that by just printing the array here, and we'll separate them by new lines. So if we were to like look at the example input, it looks like this, but if we were running to our script, we would have separated by new lines. No, it doesn't. Why didn't do that? Oh, because I need to set read, right? I need to set this to just read 1 character at a time. So what am I doing wrong here? Read -ra into an array. Let me do some testing here because apparently I am dumb. I want to read it character by character. Do you just do N1? Wait, no, don't put an A here. N1 and then -a for array. That is not, oh, right, because then it will only read 1. I need to separate them. Okay. How do you separate them by nothing? Can I do this? Or will that be a null byte? Yeah, how do you do this? Is there a way to do this? Is there a way to split characters that are just next to each other into an array? There's got to be a way, and I'm probably just missing something really, really simple. Yeah, isn't there a way to like split on nothing? Because I think this just makes it the null byte if you do this. I don't think this is the correct way to do it. There has to be a way to do it. But no buts. I'm going to figure it out. I got stuck with this last time, so I should learn it. Continue until the first character of delim is read rather than new line. No, we want to read to the new line. Use read line to obtain a line, doesn't matter. -I text, nope. Nchars, return after reading nchars. Yeah, no, we don't want that. Nope. 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 None of these are it. Is there a way to set the IFS? Let me see. Read a single line from standard input or from file descriptor if the U is applied. Nice. The line is split into fields as with word splitting, and the first word is assigned to the first name. I don't know if we can actually do it this way now that I think about it, because word splitting would have to do something between them. Yeah, only the characters found in IFS, and I'm trying to do like nothing character. Yeah, so I actually don't know if I can do what I'm trying to do here. I can do it manually, but I don't know if I can do it in one-liner. Let's see. Does bash not treat string as a char array? It does. And I can handle it just that way. It's not technically an array, so I have to use slightly different notation, and I usually mix up the two. But no, I could totally do it that way. It's not even a big deal. I'm just trying to figure out if there was a nice way to do this. Vim is pretty easy after you figure out how to exit it. Well, listen, man, I'm still trying to figure out how to exit Vim. As far as I'm concerned, it's impossible. Watching you program in bash is like me watching pro fighters fight. I can do what you do in my dreams only. Thank you. What a nice compliment. Well, keep dreaming, buddy. No. If you practice, you can get this good at bash. I don't know if you want to. That's something you got to figure out for yourself. But, you know, you can. I got faith in you. I don't think I can do what I'm trying to do. I don't think I can take a single line of input and break it into an array based on every character there without doing it manually. And you know what? I don't feel like doing it manually. So let's just read it into one giant string. So now we just have the string. So if we want to loop over, we can loop over the string. That's fine. Decompress the data. So the algorithm for decompressing the data and what it should look like, we will have a string at the end of it. So let's go ahead and make a blank string. Let's loop over every character. So let's get to do that, we need to get the length of the compressed string. This is the original string. And to get the length, we'll use this notation. This will give us the length of the string. Nice little pound sign in front of it. Now we can do for I equals 0, I less than len, I plus plus, do, done. We can say num equals no. Num is compressed at spot I for one character. So we're basically doing substring notation here. We're saying make a substring, start at position I, and only read one character. So we're just getting the exact number there. Let's prove this works by just echoing here and quitting out and running it. There we go. So we get all the data separated by new lines because we're processing them one by one. So now what do we have to do? We have to turn it into that string where we keep track of how many numbers we've encountered. We have to keep track of the index of the number. So let me think about how to do this. Let's do this. We need to figure out if we are processing free space or if we are processing a block. And the way we can do this is it always starts with a block and then alternates block, free space, block, free space. So we could set like a Boolean flag and just toggle it at the end of the loop, or we could abuse the fact that it's an even or odd indice that tells us that. So the first indice is 0, that will be a block. 1 will be free space, 2 will be a block, 3 will be free space. So if it's odd, then it's free space. If it's even, then it's a block. So the nice thing is we can say if I modular divided by 2 equals 0, this means if it's even, index is even, we have a block. We'll say block equals true. We might change what we do in these things. Index is odd. We have free space. So block equals false because it's not a block. And then what we do here, we know how much there is of the thing that we have. We need to figure out now the index of it. Okay, so if it's even, the index of it would be divided by 2, I think. Yeah, because if we're dealing with a number that's at index 9 of the original list, we divide it by 2. 9 divided by 2 is 4. That should be block number 4. We're good. Yeah, because it'll do a floor truncation of the numbers because it'll treat them as integers. So, oh, you know what we can do? We can just do char equals. So bear with me. This will be the character that we use to represent it. If it's an even number, then we have a block. Represent this block using its index. So we need to grab the index, will be I divided by 2, and then that number is our index, so char equals index. We could probably just compress that into one line, but it's fine right now. And if we're here, then the char is a period, because period is how we denote free space. I think this will work. Sounds a little weird, but what we can do here, I'm trying to think if we can test this. What is a good way to test this? For j equals 0, j less than num, j plus plus. This is very verbose. There might be a cleaner way to do this. S plus equals char. Okay. This is very confusing, but I'll explain what's going on if I get it to actually run correctly. That looks right. Let's go ahead and compare this output to what we have here. So to do that, I'm just going to paste this into the terminal so we can kind of look at the output. So if I paste it into the terminal, yeah, that looks right. We correctly generated the decompressed string. I will explain how that works. That might be confusing for people. Decompress the data. We'll call this decompressed. Decompressed. Cool. So how do we do that? Loop each character of the input compressed. No, let's do of the compressed input string, because the puzzles like to do input in parentheses. I'm going to match that energy. This number tells us how many there are. Index is even. We have a block. Index is odd. We have free space. Represent this block using its index. We can simply divide our current position by 2 and chop off the decimal place. Done automatically for us to figure this out. Cool. And then append num chars to the output string decompressed. That's how this works. Hopefully that makes sense how we're doing this. So now we have a nice decompressed string. Hey, that's beautiful, isn't it? Cool. That's really cool. Now, what do we do with the decompressed string that we have? I think the next thing we have to do is we need to figure out how to defragment it. And the way you defragment it is you start all the way at the right side of the string and you shove things as far left as you possibly can. So we will need a condition to know when we are done defragging. That's very important because we're going to do this in a loop, but we need to know what the condition is to break out of the loop. And the way that we know we're done defragging, actually I'll show the solution again. The way that you know you're done defragging is when your output string has all numbers at the beginning and then all periods at the end in that order. Yeah, I think that's it. I'm trying to think how much error checking we could do, because technically speaking, we could be given input that has no free space, in which case our totally defragmented answer will have no, well, actually, we won't have to defrag anything. So what I'm trying to say there is that the periods might be optional if we're going to define some sort of pattern to recognize this. I think regex is the answer here. I actually think we're going to look for something that has numbers on the left and optional periods on the right and nothing else. Like, it literally needs to match exactly that. So, defragmented regex. We're going to write a regex to describe what a defragmented answer looks like. And a defragmented answer looks like 0 through 9, one or many times, followed by a period, 0 or many times, end of string. That's how we will know if the data has been defragmented, if it matches this regex. So it starts with numbers, has periods at the end optionally, and nothing else. You can't intersperse numbers and periods. Like, it has to match this. You can't have periods at the beginning or numbers at the end. So now we can do this. Let's do defragmented. I think the way we do this is we make a new string called defragmented string, and we initialize it to be decompressed, and then we'll go through step by step and slowly defragment this final string. While defragmented equals defragmented redo done. We need the opposite here. We need to say while this regex does not match, do a single step of defragmentation. Okay. And then we can echo defragmented here. And then we'll just put an exit 5 here. Just for now, just for testing. So when I run this, we should have we should exit with 5. Cool. Yeah. I spelled this wrong. Defragmented. Yeah, look at that. Let's go ahead and spell things correctly. I was going to do it just one by one. Literally start at the right of the string and then start from the left and find the first period. I think the way we do this is we reverse the string and we keep a copy to this string reversed. We remove the periods from the string and then we literally just read the numbers from left to right and we keep putting them in the periods as much as we can until we are done. I think that's what we do. Initialize the final string using the decompressed, uncompressed data? I don't know, whatever. Decompressed data. Also reverse the decompressed data and remove period to just have a bucket to pull numbers from. Okay, so I think what we're going to do is we're going to have 2 strings. One is going to be the list of numbers backwards, and then we're going to read through the original list. Every time we encounter a period, but we're not yet fully defragged, we will grab from our bucket on the left and put them in. And then the moment we are defragged, there should be no more numbers to pull. I'm trying to think if this causes an issue, if we end up duplicating data, but I don't think we should. Once we're defragged, that's when we stop. We've done enough work. We're only going to pull so many numbers as can fit in the original ones. So, yeah. I think this will work. Let me think about how I want to do this. Okay. So now we have reversed equals decompressed. Is there an easy way to reverse a string in bash without piping out to like rev or cat-r? Not that I know of. So we'll just create this ourselves. For I equals 0, I less than decompressed I plus plus do done. That is not what we want. We want to set I equal to the length of this string minus 1, I greater than equal 0, I minus minus. So we want to go backwards, and then if, let's grab the character at that position, char equals decompressed I, if char not equal period, then reversed plus equal char. Cool. So this is just going to create a nice little string called reversed. Let's do echo reversed equals reversed, and then see what happens. Cool. So our reverse string is absolutely not reversed at all. What did I do wrong here? For I equals length of decompressed minus 1, I minus minus char decompressed at I, reversed is that. Also, we do have to get rid of the periods. No, we didn't actually put periods in there. What am I doing wrong here? I'll figure it out. I'm going to be doing something really, really stupid here. That's almost guaranteed what's going on here. It almost always is when I get into these little situations. Is this failed syntax? This minus 1 here? I think it is. Yeah, grab the char here, char here, char here. And then we plus equals. That should be string manipulation. What did I do here that's wrong? Yeah, it's counting backwards. Yeah, it's absolutely counting backwards. Oh. This char just unset a whole bunch of times? Oh my god, yeah, because I'm doing the thing I always do. I'm doing the thing I always do. This is a array notation. This is to grab a spot in an array. Decompress is not an array, it's a string, so I have to substring it. I always make this mistake. That's why I like to deal with arrays everywhere, so the syntax is the same. That's what I was doing wrong here. So now, when we do this, there we go. Now we properly get the reverse string with no periods. So the reverse string is a bucket of characters we can pull from to put into this final string, and then we need to chop them off the right-hand side, don't we? Let me think about that. Okay, I've thought about it. We'll just add the number of periods to make the length the same. That's an easy solution. So we have the reverse string now. So we need two counters. We need a begin counter and an end counter. So we need two things. We're going to use I and J. We'll keep track of both of them. And now we'll do it one at a time. Char equals defragmented. No, we're not going to edit it in place. I don't like that. I don't like that. We're going to make a new defragmented string. And we're going to grab data out of decompressed. That's what we're going to do. Char decompressed I1. And if char equal period, then we need to grab the number out of the thing. So instead of using that, we're going to set it equal to reversed at j. So now we have an actual char that we're going to do there. And then we're going to put that in the final string. So defragmented plus equal char. That should work. And then when we get down here, I always gets incremented, but j only gets incremented if we use it here. Cool. And now I think this is not going to fully work. This might just run forever. No, this should work. But let's just see. Well, that's not even close to working. We print the decompressed string, and then we have a string called 0. So the string called 0 is clearly incorrect. I'm guessing char is incorrect. Char was just the letter 0. Is it matching the regex? Oh, I see what's happening. I see what's happening here. This regex is matching immediately because it's just matching for numbers and a period. We don't have a full string that we're messing with. So we have to think about it differently now. Yeah, there's actually not much we have to do here. There's not much we have to do here. We just need to loop over the decompressed string again. For I equals 0, I less than decompressed. We don't even need regex. Yeah, what was I thinking? I plus plus do. We get the character out of it. We echo it. If it's a period, then we get the reverse thing, and we increment that counter. We don't need to increment that here. And then we append it to a string, and the final string should be this. So this is what it would look like when it's all pushed back together. This looks wrong to me, because why are there 9 showing up here and 9's also at the end of the string? So we are doing something incorrect here. I should actually think about what I'm trying to do here. We're looping over all the characters of decompressed, and we are putting them back in. So what's happening? Oh, we're not pulling the numbers out of decompressed at that spot. That's what's happening there. So we have to break out. We have to break out. This is tough, the way I've chosen to do this. Let me think about this. Yeah, because once we pull a character out of the reverse list, we need to remove it from the decompressed list. So it's not so much that we have to reconstruct the string. We have to figure out... Wait a minute, actually, wait. Is the valid string in here? I think the valid string is here. Oh, this is interesting. We should have the valid string, and then we have to chop it at a certain point. So however long... Oh, yeah. If we just pull the numbers out of it, then we know that that's the final length of the string. So if we just pulled the numbers out of it, which we did, the reverse string has just the numbers in it, we need to take a substring. Defragmented equals, we need a substring defragmented to be the length of the reversed list. Oh my god, this is wild. Because this will be how many numbers should be in there. So now if we do this, we'll get a way smaller number. Cool. See how it stops here? We've taken a substring of it. This is the right answer. We just need to put all the periods over here, and it should be there. So the number of periods we need to put will be the same as... Oh yeah, wait a minute. Oh my god, this is funny. The number of periods we need to put is the decompressed data with all of the non-periods removed. That's it. So let's remove all of the non-periods from this string. And I think this will work. There we go. I think that's it. It's a little bit gnarly. Might be a little bit confusing here. Let's see. Also reverse the decompressed data and remove just to have a bucket to pull the numbers from. Loop every char of decompressed and construct a new string, optionally pulling the char from the reversed list. At this point, we have a valid string with invalid numbers at the end of it. Chop off those invalid numbers and replace them with all of the periods that should be there. There we go. Now we have the valid. There we go. Okay. And let me just, I'm going to double check this. This is the correct, I'm going to take the correct thing from my web browser. You can't see it. I'm going to paste in the terminal and it should look right. It's just off by 2 characters because of my prompt. Looks right to me. Now that I have this final string, the final step of the file compacting process is to update the file system checksum. To calculate the checksum, add up the results of multiplying each of the block's position with the file ID number it contains. The leftmost block is in position 0. If a block contains free space, skip it instead. So from the first example, we take spot 0 shows up 0 times, spot 1 shows up this many times, spot 3 shows up 9 times, so you have this, or spot 2, not spot 3, because it's indexed at 0. Okay, and then you add all of those up. Okay, this part's super easy. This is just a proof we got the right answer. Cool. So for I equals 0, I less than the length of defragmented, do, I plus plus, do, done, num equals, we get the character at that spot, and we're going to use the right notation. Cool, so now we have that. If num equal dot, then we don't even need to continue. We can actually just break out of the loop because we know all the dots are at the end of the list. Otherwise, we will say product, and we will multiply them together, equals num times I, and then accumulator plus equal product, and we'll have to just go define accumulator above as 0, and then echo checksum equals accum. So if I run this, according to this on my website right here, if I run this, I should get 1928. That's what I should see if I run this. So let's go ahead and run that. 1928. We got it. Look at that. It works on the example input. So nailed it. I'm going to go ahead and we're going to run this on the real input. Now the problem is the real input is gigantic. So what I'm going to do is I'm just going to get rid of some of these echo statements because it's going to be gnarly. Where do I echo things out? There we go. Just get rid of those echo statements. So now we just have one line. Awesome. So let's go ahead and run this on the real input. Do you think it's doing anything? I don't think this algorithm should be that difficult. Is it doing anything? I might quit this and go put some echoes or something. I might be stuck in an infinite while loop. Nah, it shouldn't be happening. Let's go ahead and put some, that's not what I wanted to look at. Let's go ahead and figure out why we're stuck. So let's go ahead and add some of this stuff. Echo reading data, echo decompressing data, echo defragmenting data. Do we use this regex anywhere? I don't think we do we? No, we don't. Let's get rid of it. Echo generating checksum. Let's go ahead and see what's going on here. Okay. Oh, okay. So it's doing something. Something's happening here. So it must be the defragging. That's taking a little bit. That's fine. Echo defrag step I of decompressed. Did it not make it to this part? Please don't tell me it's sitting there reversing a string. I feel like that shouldn't be that slow of an operation, right? Kernel panic, yeah. Doubt that. Guess we'll find out how bash string operations are. In bash, yeah, no, the string operations are terribly slow in bash. Add debugging for every n times 1,000 iterations. How about just every n iteration? After this, we can start optimizing it so it finishes in 0.1 seconds. Hey, let's make it so it finishes now. Let's see. Let's do a bash minus x. We'll get some debugging on this. Is it really just reversing the string? Is that what's taking it so long? Like, I understand that that's not the fastest way to do it. Yeah, I could just pipe out to rev. I mean, that's probably the fastest way. Echo reversing string. Echo done. I think this algorithm is good. I think it's just incredibly slow. Let's run it without the debug output. Okay. Yeah, so we're reversing a string with that many characters. It's just too hard for it to reverse. Is there an easy way in bash to reverse a string? Yeah, I mean, if that's the case, we're just not going to reverse it. Let me think about this, because reversing strings is ideal. If it's that hard, we might just have to not reverse it, instead just index it backwards. That might be the way to do it, sadly. Let me think if I can come up with a clever solution to reverse a string without having to pipe out to external tools. If I have to pipe out to external tools, it's not the end of the world. How would you do it cleanly? Because I just think character by character. You don't need it if you use 2 pointers. That's what I'm thinking, if we just reverse index the original string. The original string does have periods in it, of course, so I just have to filter those out, but that's okay. Let me think about this. I can't think of any built-in way to do this. Yeah. You could totally just... I could pipe out the sword, I could pipe out the tack, I could pipe out to a whole bunch of stuff. I'm trying to think if there's a way to do it in pure bash without having to fork. But I don't think we're going to be able to. I don't think bash has a built-in mechanism. Like, I mean, it does have a built... Like, I can do it in bash. I'm clearly doing it. It's just once the data gets sufficiently large, it becomes kind of crazy to work through. Even this defragmenting step might just be so slow just because of the nature of the language. But yeah, so if we were to skip the reversed string, here's what we would have to do if we were going to skip the reverse string. So if we're going to do that, if we didn't have the reverse string, we would have to set this to decompressed minus I. We'd have to set it there, and we would just point backwards. I don't know if I feel like doing this. Let me think. All right. Well, listen, guys, we tried. We might have to use some external tools. How portable is a rev? I know there's also tail minus R on some operating systems. Yeah, I can't think of a way to do this in bash that isn't slow as heck. So if we just do this and we pipe it to rev. Oh, not rev. Tail minus R. Tack is what I was thinking of. Yeah, tack. This is not on Mac by default. Yeah. It's either going to be tack or tail-r, which kind of sucks. But, you know, hey, it is what it is. Oh, no, it is. You're right. You're right. It is one line. We can just use rev. How portable is rev? That's not a POSIX command, is it? Where does rev come from? I don't see anything in here about POSIX. But let's just rev it. Let's just rev it. And in fact, let's get rid of all of the periods here while we're doing it. So now, okay. Let's go ahead and run this on the example input again to make sure we didn't break anything. Checksum is 0. Okay, so we broke something. Oh, because I started making some changes down here that I didn't actually undo, right? No, I didn't. I undid those. Okay. This might have just gotten rid of everything in it. Let me do some testing. Okay, they both work how I expect them to. Oh, yeah. I'm dumb. I'm doing this on an empty string. It's decompressed. We haven't defragged it yet. That's all it is. It's the remove of the dot. It's not. I was using the wrong variable name. Let's see. I know tack is cat backwards. Isn't that cute? How funny is that? 1928. Okay, that looks right. Let's do this on the real input. Okay. Okay. So we are about 10,000 iterations into 238. That's actually not that bad. I'm going to be honest. That's not that bad. Like right now, we're about to hit 20 out of a little bit. When we hit, what, 23,000? Okay, we're 10% of the way there. That's not as slow as it could have been. Yeah, there's no good way. There's probably some optimizations here. There's no good way to parallelize this. The console prints might be slowing it down. That's very true. That's very true. That could be a big thing that's slowing it down. Nah. Oh, I said we're 20%. Did I say we're 20%? We're 10% of the way in. Now we're like 20%. That's cool. So yeah, echoing it could definitely be slowing it down, but we're so far in, I don't feel like changing it. Let's wait and chat. Hey, I'm down for that. My Vim question scrolled by. How do you comment, uncomment a block of text? How do you do it in Vim, or how do I do it? Because how you do it in Vim, I have no idea. How I do it is I press 0 to go to the beginning of the line, I press I to go into insert mode, and then I hit Shift 3 to make the pound sign appear. Like literally, there's a Vim way to do it. I don't use it. I literally just put in and out the comment character. So I don't know what the proper way to do it. Do a log every 10K? Yeah, honestly, probably should have done that. Probably absolutely should have done that, but I think we're too far in now. I'm just going to let this run, and we'll see what happens. Using bash to defrag a hard drive. How beautiful. This is part 1 or part 2? This is part 1. Yeah, you're right. Let's sit here and chat. See if any girls are texting my phone. Oh, no one? Cool. That's not true. My buddy's actually sending me memes. All right, I'm going to be right back. I'm going to let this run. I am going to go grab something to drink. All right, I'm back. I usually show line numbers, then use a regular expression. I've done that in the past. Yeah, I don't have a fantastic way. I'm trying to think. I've done some... I normally don't have to comment too much stuff out, especially like as I'm developing. Usually I'll just put like early returns or early exit statements if it's bash. Or if it's Rust, I can just, /* to open a comment and then */ somewhere else to close it way later. Let's see. Oh, that's cool. You have a vim config thing to actually like do commenting. Yeah, that's cool. Yeah, I guess I've just never needed it, so I haven't worried about it. Only part 1 probably should have saved output to files. I'm like, whatever. I don't know what part 2 is. I'm not going to sit here and like, I'm not going to worry about part 2 till I get to part 2. Otherwise, I would just be needlessly anxious about the future for no reason. And I have my life to do that with. Yeah, Control V to use something like multi with cursors. It's similar. I don't know if you can do like a multi-insert with it. Sometimes I will like Shift V a whole selection, and then I will use that syntax that Matt talks about where I use a little regex to just do it. Cool, so we've hit the last defrag. I don't remember what comes after that. Oh, generating checksum? What are we waiting on? We should have put a print here. Yeah. So now I have no idea what it's waiting on. When stream of writing RISC-V emulator in bash? Never. Listen, I'm sure anything will be faster than how I'm doing it. What did it even do between the defrag and the generating checksum? Because like I didn't even pay attention to that. I should have put... I didn't even think we'd get that far. I should have put debugging around the generating the checksum. Also, we're getting the sum of a very big number. Do we have to worry about like 64-bit integers over here? Are we gonna... Is that a possibility? I mean, probably not. We're probably okay. Just kind of curious. Oh, hey, we have a checksum. That's a number. And that, yeah, that definitely fits within 64 bits. Does this fit within 32 bits? 1, 2, 3, 4, 5, 6, 7, 8, 9. So what is this? 89 billion? This is 89 billion, right? If it's 89 billion, then no, it doesn't fit in a 32-bit integer. Yeah, it's 89 billion. So that would not fit into a 32-bit integer. It would have to be 4 billion or 2 billion if it's signed, which numbers are signed in bash. No, not bad, but like, yeah. Either way, it's not fitting. So let's see. We have a checksum. We have a checksum now. That took a long time. Let's go ahead and test the checksum. Are you guys ready? Let's see if we did it. That's not the right answer. Your answer is too low. Whoo! That is not the answer. The answer is too low. Ooh, how much does that hurt? That is crazy. Be careful copying and pasting the input for the puzzle. It's a very long line. Yeah. Did I get the input right? I most certainly did. All right, here's what we'll do. We will take low checksum. We'll save this just so we have it. I don't know how costly it is to get the length of a string in bash, but any sort of optimization here helps. So that's what we're going to do. I don't think we need to get it again, but it's fine. Cool. I think this is where it took a breath. Echo, fixing defrag, string, echo, fixed. I think this is what took time. So yeah. Yep. Echo, take a breath. Yeah. There we go. So now, let's run this against our example. And we get syntax errors. That's so sick. What did I do wrong here? That's what I did wrong there. Oh, which means it's going to be duplicated in this code. Cool. No, this is right. Oh, I got rid of that semicolon. Okay. Taking a breath, fix, generating checksum, 1928. Okay, well, this thing generates a checksum just fine. Here's what we can do. Once we have this data, echo defragmented into defrag.out. We will write it to a file. That's what we will do. Yeah. Let's just run it a little bit just to get an idea of what's going on here now. I probably won't let it run the whole way through, but we'll at least see what's happening here. Okay. I can't tell if that's faster because we're not printing as much. Anecdotally, it feels faster, but I'd probably have to check the VOD or do some timing around it. I could print timings. Yeah, maybe I could make like a time start, time stop function to put timing around this, just so we have an idea. The question is, what are we doing wrong? You know what we do in that final step? We put those periods back into that string, and then we loop over that string, and then we break when we encounter the first period. So that's just a minor optimization we could do. We could just get rid of that free space periods. We don't need them. They're not part of the checksum. This feel... Am I crazy? Does this feel a little bit faster? Probably echoing to the screen is definitely a thing that makes it slower. So anecdotally, this feels way faster. You might print the checksum periodically and make sure you aren't getting some overflow. That is a great idea. That is a fantastic idea. Are we sure about the input? Sometimes copying huge single line breaks it. You're right. You're absolutely right. I should go grab the input again just to make sure. I'll grab the input, put it in a new file, and then diff the two to make sure. Possible edge cases. Example data starts and ends with numbers, question mark? Does it? I have no idea. Yeah, and the example data. Well, I mean, we should always start and end with numbers. We don't have free space at the end of the number. I think that's a thing. I think it's typically the puzzles don't throw stupid little things like that where they throw free space at the end. They'll have like a number. It'll be an odd number. And when we did a word count -c, it was an odd number. It showed up as an even number, but that's because I was counting the new line character. Oh, the interesting thing about the checksum step is it doesn't have to do this many steps because like half of them are going to be periods at the end. So this thing should break way before it hits 20038500. So I can factor out those periods and actually get a more telling number. Was this the same one? All right, so we got the exact same checksum there. Let me go ahead. I'm going to unshare my screen right now. I'm going to get my puzzle input. I'm going to go here. I'm going to save as, and we will save as input.txt on my desktop. Okay. Now we are going to go back to my terminal, and we're going to cp from my desktop input.txt to save as input.txt, and we're going to diff real input to save as input. They are identical. Those files are exactly the same, so we can rule out any sort of bad data from a copy and paste thing. What do we have now? We have the defragged output, right? Oh, it's going to be wild to look at. Oh, cool. So I did put all the periods at the end. Trying to grab the scroll bar. Oh, my God. What do you guys think? Does this look right to you? Off by 1. You know what the worst part is? Imagine if I took the checksum that I generated, added 1 to it, submitted it, and it was right. I would be so mad. Oh my god. All right, let's do some work here. Let's figure things out. So we can speed this up by not appending back the periods. And if we don't append back the periods, then we don't need to even do this check here, because this check will never work. I think we can do this in one line, which will probably be faster than having to do mathematical expressions, save it to a variable, and then go back. Why are we looping over the length of decompressed and then accessing the length of defragmented? They should be the same. They're not now, but they should have been lined up like this. We get the defragmented. We grab the variable that we want out of it. We know the index of it, and we multiply it by whatever number was there. And then we add it to our accumulator. This looks fine. Okay. 1928, we still get that. That's good. That's good. I do like the idea of echoing the accumulator. This is going to be long. But yeah, we can see that accumulator being built up. We write that to defrag. Okay. What we want to do is we have the defragmented output, right? Oh no. Because I ran the example input, it lost the defrag from the longer output and overrode it with the example output. How funny is that? Oh man. Darn it, I should have saved that, because then we could have just rerun the checksum logic to make sure that it looks okay. That's so funny. That's so funny. We'll do some stuff here. So what I'm going to do is we can generate that defragged output, which is pretty nice. And then when we have that defragged output, first I will CP it to a safe file. So we'll have it. That laugh was full of pain. Oh, it's fine. I mean, I've like RM'd weeks of work before. Like this is nothing new. I've been here before. We're having fun. I will save this output, and then we will have it. And then I will write a script that will just do the checksumming logic. And we can see how that fares. We may be able to do the checksumming logic faster. I have a way of doing the checksumming logic, I think, a lot faster. So hear me out. We'll use awk. We will take this defragged output that we generate, and we will inject new lines between every single character, and then we will use awk to get the field number and the number that shows up in it, and then we'll add it to some sort of accumulator. I think we can do it this way. There will be some work that has to be done to get us there, but I think we can do it this way. Oh, there's going to be some sort of math hack. Of course there is. I'm a programmer who doesn't know math, so we're brute forcing this. I accidentally RM-RF when I meant to LS. Yeah, that's, I mean, I've done it too. It sucks. It sucks. I don't do it anymore, but I used to have an alias or a function where if I was trying to RM-RF something, it would throw in a -I, which would make it interactive and it would ask me. But I just got frustrated by it. It's sort of like, oh, my gun used to have a safety on it, but I got annoyed by it, so I took it off. It's like, Yeah, my car kept beeping at me because of my seatbelt warning. It's like, maybe that's a good thing. I don't know. Oh, man. I don't know if the space step separated string thing would help. Because I actually don't even know what the problem is right now. Also, I should probably do some performance testing with Bash. Like, if I have 100,000 long or 1,000,000 character long string or 1,000,000 spot array with one character in each, which one operates faster? Which one can I index faster? Because now that I think about it, it's probably the array would be way faster. It might be worth it to put things into an array. That's the beauty of the Mac Studio, man. The M chip Mac that I'm running, I can make Bash hammer the cores and you don't even hear the fan kick on. All right, we're almost there. Less than 10K steps left. What do we call it? Defrag.out, I think. Okay. Well, the accumulator seems to be doing something. Let's cut out of that. Let's CP defrag.out to defrag.real. Okay, now we have this, and we are good. This is safe. This is what my defragmented string looks like. This is crazy. Okay, so this is what the string looks like. I need to inject new lines between every single character. What's the easiest way to do it? Sed? Can I just do like that? It must not be empty. Can you just literally do dot? And then do I have to back reference one? How do you do it in sed? Sed's always different on every operating system. What's the logic on the checksum again? Right here is to take your final string and you read it from left to right. You take the index of this, so this is at spot 0, and the value, which is also 0. You multiply them together, you get this result, and then you add all those results together. Let's share this again. How do I inject new lines after every single character in an input stream using tools and not like a while loop? Like normally I would just do like some sort of while loop or something. Every version of sed is different, so that sucks. It's like this. Wasn't there like some weird syntax like that? Yeah, I don't know. There's got to be a way. What am I thinking here? We want to take every single character and append a new line to it. I feel like sed is the right answer, right? Sed is absolutely the right answer. But I don't know how to do back references in sed. What if I just put like, you know, a comma here? That doesn't show up anywhere. This says it's, yeah, so there's something wrong here. Well, that's not even doing anything. There we go. There we go. Look at that. Now we do just have a blank line at the bottom. That's kind of annoying. This is going to be pretty gross, but we can just grep that out of there. And now our data is prepared for awk. So awk, let me do some testing here. Printf foo bar baz. Cool. So we have this. Let's pipe that to awk. And then what is it? Is it the NF for the number of the field? This should give us the index. No, NR. It's the number of the record. Oh, it's off by 1. Can you just do -1? You can. Okay. So we can do index equals that. Num equals $1. IDX plus num. I think that's how we do it, yeah. Now we just need a begin and an end. So let's do begin. We'll set a cum equal to 0. This is going to get gnarly, folks. And then that'll run for every element in there. And then end. I'm going to have to just do this in a script. Yeah, we're going to do a script. We're going to do a script. Is it awk-f-s? What is it for a script? What do you give awk to make it for a shebang? You have to give it something. Isn't it like awk-something? I don't remember off the top of my head, but we'll figure it out. Begin. Cum equals 0. Down here, we'll say IDX equals the number of records minus 1. The num equals $1, which is whatever the number will be. And then a cum plus equal IDX times number. Cool. And then end, we will printf. A cum is this. A cum. There we go. There's some awk for you. Let's see. grep-o dot will split by car too. Oh, will it really? Oh, cool. Echo ABCD, grep-o dot, echo ABCDF, fold W1. Oh, the fold command. I always forget that it exists. I literally forget that it exists. So if I were to like example this, oh my god, yeah, that's so much nicer. Thank you. What a good solution. So I don't remember if this awk is going to work or not. Or I don't know if this awk is going to work or not. Let's go ahead and generate the defragment for the example. Okay, cp defrag.out to defrag.example. Cool, now we have an example one. Cat defrag.example and pipe it into our awk script. What do we call it? Checksum.awk, cat defrag.example, pipe it into checksum.awk, and yeah, do you not need this? Wasn't there something? Isn't it -s? Okay, well, we're getting some sort of syntax error. Where are we getting a syntax error? Is it just this? I'll be honest, I haven't made an awk script in a million years. Yeah, something seems wrong here. Is it -f? Okay, it might be -f. I think you're right. You're right. Thank you. It's -f. Okay, I don't know where I was coming up with that. This is just not running. Oh, right, because, yeah, I have to separate them. I have to do grep-o dot. There we go, 1928. Okay, cool. Now given defragged output, we can generate a checksum. So if we give it defrag dot real. Awk is so much faster than bash. Awk is so much faster than bash. That's insane. Wow. That is insane. That is insane. 0.07 seconds. Wow. Now the question is, it probably gave me the bad checksum, right? Yeah, let's go ahead and submit this. And I think it's still the wrong one. Let's just go ahead and do this just for our own sake so we're not crazy. And it's wrong. The answer is too low. Okay, cool. So we know that our awk script is working. Our defragger is just not working. But it gives us the same answer. So we at least know that is the case. But really fast. Yeah, exactly. So our logic to defrag the drive is incorrect. Now, why is it incorrect? If I look at the real output, all right, it's one string, yeah. Okay. So let's go ahead and figure out what could be wrong. So we have compressed data. I want to do some testing real quick. I think I can append to a string faster by using printf. Not that it will append to the string faster, but I think I can append multiple characters using printf. I think you can do something like this: %s, percent star s. I think you can do this, and then I can say like 5f. That put 5 spaces there. I want to repeat the character 5 times. Is there a way to do that? That put 5 spaces there. That's nice, but not what I want. Yeah, that's spacing out. I thought there was a way to like repeat the string multiple times in there. Like a repeat character thing. Let me think. What am I trying to do? I'm trying to repeat a character 5 times. I thought you could do it with this, but maybe not. This puts it to the left, yeah. And that puts 5 spaces at the end of it. What I could do is just make it 5 spaces and repeat the spaces. Whatever. We have the decompressed data, and then we have the defrag data. What could possibly be going wrong here? Let me think. What does our algorithm do? We loop over our decompressed string. We grab a character from it. If it's a period, then we grab a character from a reversed string. And then we increment that. And we put that character in that place. Yeah. And then we keep doing that. And then when we're done, we can break out of this way earlier. Yeah. Let's speed this up while we can. Num appended equals 0. Num appended plus plus. If num appended equals len, nah, we need the length rev len. This is so dumb. This is just the length of all the numbers in there. Once we hit that revlen, then we're done. This is just an early escape. And then because we're putting that here, we can do this all in one. I think Bash supports this kind of notation. All right, let's try part 1 with the example input. Okay, I printed out a whole bunch of stuff during that checksumming, didn't I? Yeah, we don't need that because we have a working checksum thing in awk, which is awesome. Cool, so now we should have decompress.out, nice, and defrag.out. And okay. Defrag step 0 of 28, checksum step 0 of 28. Okay, so it does way less steps now, which is super nice. Wow, it still takes time to just fork out to rev. Okay, well there's less steps to do now because we're defragging. We don't have to keep doing extra logic. Let me think. Echo the accum inside the if for each 1,000. I might. I don't suspect it's a problem with the accumulator because I have the awk version of it, which I can just test. So if I did, I would test it with the awk version. Let's see what this does. We're looping over the string, the decompressed string, and every time we encounter a period, we're replacing it with a number from the reverse list. And once we've constructed a string, something's not right. Something's not right. Something's still off about this. I don't suspect we get the right answer from this, but there's still more to do, so we shall see. This is right in that zone where it's like, it takes a long time, but not too long, you know? Not long enough where I won't sit here and wait. I don't want to sit here and wait for it to generate a checksum of that. We now have defrag.out, so we can cat defrag.out, grep-o dot, pipe it into checksum.awk, and generate a checksum. That looks like the same one. I mean, of course it's the same one. We haven't done anything to actually fix it. But that's good. We are consistently generating the same checksum, so our checksum logic is almost certainly sound. Like, this is the world's simplest logic. We can go ahead and printf this for every single iteration. It'll be a lot, but like that grows in a way that makes sense. Like, I'm okay with these 0, 0, 0, 0. Are they all zeros at the beginning? They might just all be zeros at the beginning. They are. So I have all zeros and then 999. Okay. Okay, that makes sense. Now what if I vim my real input, go all the way to the top? And so it shows up 5 times, then 4 free spaces, then 7. So we should have 0 5 times and then 4 random characters. And then we should have some 7s. Oh yeah, then we should have 1s. Yeah, okay, cool. I mean, this logic looks right. Okay. What amount of data are you decompressing? I don't really know how to explain that. There's too much to explain. Let's see where we are here. Yeah, my checksum logic seems fine. It's going to be the defragging that is just wrong. So let's go ahead and figure out why. If the number of things that have been appended to this string. So like, you know, we've now appended 1. So the string is of length 1. If that is equal to the length of the reverse string, meaning how many numbers there are, then we break. We are done. We have defragged the disk. Now it's time to go through. Yeah, we don't even need to do this. There's no reason for that. And then we have to go through and generate the checksum. Okay. That's good. While we're at it, maybe convert it to an array. Yeah, it might be. That might be worth it. Especially because I could change the algorithm around a little bit. If I convert it to an array, then I can actually just swap the things in place. Like that might be the better way to do the defragging, is actually just swap them in place. But this algorithm should work. Yeah, we're going to do a single step of defragmentation. The way we do it is we look at the character of the decompressed string. If it is a period, then we need to grab a string out of the reverse thing. This is what we care about here. We grab the first number from the reverse list of numbers, and then we increment the number of our reverse number pointer, and then we append that to a defragmented char thing. So we just do defragmented plus equal on this, and now this has become part of defragmented. Where's defragmented defined? Here it is. It's an empty string. Cool. And if the number that we have appended is equal to the rev length, the length of the reverse string, then we're done. That feels right. Like that feels just absolutely right. What could be wrong about this? Defrag.out. Yeah, like I'm going to look at this and have it make sense. So this is what the decompressed string looks like. Twelve, 12, 13, 13. What numbers am I putting in there? 11, 11, 12, 12, 13, 13, 14, 14. How is this supposed to handle 2-digit numbers? Is it supposed to handle 2-digit numbers? Wait, what am I doing? Am I doing something real weird here? Because a 2-digit number, if I'm reading it character by character, 2-digit numbers don't exist. They're just 1 digit. Yeah, hold on. Yeah, I use the iteration. These are all just numbers. There's no such thing as 2-digit and 1. There's always going to be 1-digit number. The only thing that could be 2-digit is the index. But we're just grabbing something at that spot. We're not using these variables for anything. Yeah, we're literally just using the I variable here. And then in our defragment step, we're just using it here. Oh, that's checksum. Oh, God. Oh. Is this right? Hold on. This is the index to pull the number out. Oh my God. Hold on. Something's not adding up here. Why are we putting the index in here? Why do we get this number? Index is even. We have a block. Represent this block using its index. We can simply divide our current position by 2 to chop off the decimal place to figure this out. Okay. What? This doesn't seem right. What about when you get to indexes above 9? Hold on, I think I'm fundamentally misunderstanding something here. Using one character for each block where digits are the file ID and period is a free space, the disk map 1, 2, 3, 4, 5 represents these individual blocks. The first example represents these individual blocks. 0, 1, 2, 3, 4, 5, 9. The amphipod would like to move file blocks one at a time from the end of the disk to the leftmost. This is what they want to do, but I don't think I was ever meant to represent the data this way. I think this is just meant to be a visual representation for me to understand what's happening. I don't think I'm meant to represent it this way, because when I try to represent it this way, we're going to go well above those numbers. You need other symbols, the ID. No, I don't. No. I don't need other symbols. I would need an unlimited amount of symbols. I don't need to create this visual representation of this. This is just for me to understand what's going on. I just dove right in and started representing it this way. I shouldn't ever even try to represent it this way. I should just work in it in one step. Yeah. Damn. Okay. How do we do this? Build a file system. Yeah, exactly. Oh, man. Okay. This is the index of the block. And this is where we need to store it. Okay. I have such a garbage solution to this. I have such a garbage solution, but it's so janky. For every block, instead of writing one number, we write like 4 digits. And we just hope that 9999 is big enough. I have to approach this so differently than I've been approaching it. Wow. Okay. I have to approach this so differently than I've been approaching this. I don't know how we're going to do this in Bash. Does Bash support 2D arrays? No. That's why this might be a problem. Because I just need a string of... it's not a string of data. It's a collection of blobs. It's a collection of things. It's got to be an array. Let me think about this. We're just going to start doing it. I'm not coding. I'm just going to... we're not thinking, we're just going to code. All right. So we have the compressed data. And we have if it's a block or not. We know the index of it. So that's the char we should be using. All right. Let's try this. Instead of a decompressed string, let's make... make a new array. And then we will append this to the array. Already, this is going to be so much better. So we have this new array called B. Yeah, let's just use the existing variable names. Decompressed. So now we have the decompressed data and it's in an array. Let's go ahead and printf everything that's in there, separated by new lines. Exit 1. Okay. 1, 2, 3. Okay. This looks nice, and it's in an array format, and it will handle multiple digit lines. All right, let's see. Decompressed, we have it in an array. Nice. Now we need to defrag the disk, and the defragmented will also be an array, not a string. And we need to let's get rid of this logic. J equals length of decompressed. Now I can use that syntax because it's actually an array. All right, let's think about this. For I equals 0, I is less than ling, I plus plus. Okay, now we're going to do the defragmentation. Do a single step of defragmentation. So we have to get the character out of the decompressed thing at spot I. All right, and if it's a period, what we need to do is we need to find the character at the end of the array and bring it back to the beginning. Let's see. So we grab it out of spot I. If it's a period, then we need to find the first number at the end of the list. So we're going to walk this list backwards until we find a character. New char, decompressed at spot J. Let's do this. If new char not equal to dot, then we found one, break, swap them. So now we're going to swap them. So we basically walked the list backwards. That should be minus minus. The same list here, we found a new number going backwards. So now we are going to swap them. And, ooh, I don't want that here. I'll have to think about where I put this J minus minus, but we'll get there. We'll get there. So if we have a new char, we have to take whatever's at spot I, so swap them. So we'll do a simple, temp variable decompressed at spot I. We'll set decompressed at spot I equal to decompressed at spot J, and that decompressed J equals temp. So just a simple swap. And now that we've done that, we can break out of the loop. We need to do the J minus minus here. Actually, that's fine. Yeah, because then we can just start J at len. Cool. And we just keep doing that. Okay, that's fine. And then we need to know, like, when we're done. And I think we have to go back. I think we go back. Because we have this array called defragmented. Yeah, we do have an array called defragmented. And it's going to be set to whatever decompressed already is. We're going to copy it. So now we can do this. Cool. Now we need some sort of condition to know when we are done. When we are done. Yeah, I think you're right, less than J, because that's when they swap, right? And once they swap, then I know that there's no more work to be done. I think you're right. I think that's right. And then if we're here, we don't need to do any of this stuff. We could still echo out the defragmented data. Put new lines in it, defrag that out. And then we have the generate checksum logic. Let's go ahead and run this. That didn't work. Maybe it did. Where do we print stuff? Oh yeah, so this defrag step will keep going down as we defragment more and more. That's kind of neat. Okay, so now this just needs a change. Yep, and then wow, yeah, there's no way that ever would have worked. I don't know what I was thinking, guys. that was messed up. Why are you not running bash minus x? I could. Sometimes the output's just a little bit gnarly if you do that. Yeah, smart move. Oh, yeah, because it's I hate this. Mixing array and substring notation is the most annoying thing. Okay, cool. I think we're done. Thank you for the bash minus x thing. Still getting 0. Oh, yeah, right. Okay. This looks better. It looks more defragmented. What was that noise? Nothing. Cool. What am I doing wrong? Wait, oh wait, was that a defragmented thing that I just printed? Well, that doesn't look defragmented at all, does it? None of that looks defragmented. Oh, because I'm stupid and using the wrong variable. Haha. This is gonna be a fun video edit. Oh my god, mistakes all around. Okay. Okay. I don't see anything wrong with this logic. And we're outputting it there. It's gonna be something here, right? Oh, I printed swap a whole bunch of times. Is there something wrong with my swap logic? Shouldn't be. These I's and J's should just work. Yeah, that makes sense that we're swapping it with that, but that's not right. Oh my gosh, guys, I'm stupid. We need to grab the J one? No, wait, no, nope, nope. I'm still stupid, ignore me. Alright, so this should be a number now. Okay, cool. And at J, it should be a period now. So it should be number period, number period, number period. Okay, cool. So we're successfully swapping them. Why doesn't it look like we are? That's what I want to know now. Let's go ahead and do this. Let's see what happens here. Okay. I just don't understand why that defrag output doesn't look good. This does look good. That looks way better. Okay. Yeah, that looks like successfully defragmented output. So if it's been defragmented, then I should just be able to run it through checksum.awk, right? And then I could do something like this. Can I just do that to say like if it's a number? I think you can. 1928. Okay. Yeah, so we have that working. So what if we tried to run it against the real input, right? I think so. Let's try it. Let me get rid of those comments that I put in there. Cool. And then real input. We'll let this run. We'll see what it does. Oh, look at that. That's really cool. Why are there so many less steps? Am I crazy? Oh, no, of course there's going to be less steps. Of course there's going to be less steps because there's less numbers. Right. Let's see if this works. You guys ready? Nailed it. That's so much easier than I was making it. Dude, I should have reached for a raise from the beginning. I don't know why I thought to represent numbers as multi-digit, like, what was I thinking? I don't even think I was thinking. I don't even know what happened there. That was insane. I don't know why I was thinking that. We nailed it. We did it. Good job, us. But, like, what was I thinking? I took a visual representation and then tried to copy it, not thinking that, like, I would lose data and the integrity of the data by doing that. First try. First try. That's right. I haven't been streaming for, oh my God, 2.5 hours, and I only did part 1. Bruh. That's crazy. Part 2. Upon completion, 2 things immediately become clear. First, the disk definitely has a lot more contiguous free space, just like the amphipod hoped. Second, the computer is running much more slowly. Maybe introducing all of the file system fragmentation was a bad idea. The eager amphipod already has a new plan. Rather than move individual blocks, he'd like to try compacting the files on his disk by moving whole files instead. Oh, okay. This time, attempt to move whole files to the leftmost span of the free space blocks that could fit the file. Attempt to move each file exactly once in order of decreasing file ID number, starting with the file with the highest file ID number. If there is no span of free space to the left of a file that is large enough to fit the file does not move. Oh, God. Okay. The first example from above now proceeds differently. Okay, we have all this. So we have 9, 9 twice. We try to move it as far left as we can. And there we go. There's our space. Then we have 8, 8, 8, 8. We try to move that as far as we can, and it doesn't go anywhere. So then we try to move 7, 7, 7 as far as it can, and it does fit here. So then we try to move 6, 6, 6. It doesn't fit anywhere. We try to move 5, 5, 5. Doesn't fit anywhere. We try to move 4, 4, 4, and it does. And then we try to move 3, 3, 3, and it doesn't. Okay. The process of updating the file system checksum is the same. Now, this example's checksum would be 2858. God, I hate this. Okay. Let me copy part 1 to part 2. Let's go. So we're reading the data. And we are getting that new decompressed data of it. Okay, we have the decompressed data. So now our logic for defragmenting the drive will have to change. Instead of defragmenting block by block, we are going to defrag file by file. All right, all right. How are we going to do this? Let's see. I have to think about how I want to represent this data. Because we know how many blocks there are. So we might have, 5 blocks of 0, and then 5 free spaces and 5 blocks of 1. And then we have to go all the way to the right and try to see if we can squeeze in something there. If it helps, I know how to do this in Python. Nope. No hints, please. Unless I get stuck and ask, I'm gonna tough this out in my head. I'm gonna figure this out. Taking the glasses off, we're gonna really focus. Let me think about this. How do I want to represent the data? I've written memory allocators before. This is very similar to it, where you have data and you have metadata. I think that might be the way to do it. I think this is how I would do it. Now, I don't know how I'll do it in Bash, but in a different language that had, objects and stuff, what I would do is I would have, I would make a page. This is just a word, just a page, and it would know what file it had. So here, I'll show you a visualization. So I would have a page that knew that it was responsible for file 0. File 0 took up 2 spaces, 2 bytes, whatever you want to call it, and file 0 had 3 free spaces after it. So it'd be a struct, and it would know my name is 0, I take up 2 spaces, and I have 3 spaces of free space after me. Then I would have another struct where I would say my name is 1, I take up 3 spaces, and I have 3 free spaces after me. And then I would have a linked list of those things. Then what I would do is I would loop the list backwards and say my name is 9, I only take up 2 spaces, where can I go? So I would start from the left and be like, oh, hey, my name's 0, I have 3 free spaces, you could go here. So 9 could be like, oh, I'll move there. 0 will update itself to have 0 free spaces. 9 will have 1 free space, and it will come before 1, 1, 1. This is how I would do it in C. This is how I would probably do it in like Rust or something. I have to figure out how to translate this to Bash. This is how I would do it. Because I'm in Bash, I have to do things a little bit crappy. I'll have to make 2 arrays to store this data. I'll have to make 2 arrays. One will keep track of how much free space there is, and one will keep track of the size of the data there. And I might need, literally, because I want an object with 3 pieces of data in it, I might need 3 arrays and to keep them all in sync, which super sucks, like super sucks. But I would have 3 arrays where the first spot of the array would be like the number of the index of the data that's there. The next spot would be how big it is. The next spot would be how much free space comes after it. And then when it comes time to swap, I just have to swap all of them at the right way. Ah, man. Part of me really does want to reach for like a different language because I could probably bang this out in Rust so much faster. But I feel like the challenge is in Bash. I know I won't be able to do Bash forever. I feel like I'm going to hit a point where it just becomes too difficult to do this in Bash in a reasonable way. But for now, we're going to try, and we're going to try our best. All right, you ready? We've read the data. Here's what I'm going to do for now. I'm going to just trash all this code down here. We still have it in part 1. Oh, you can't see my terminal. In part 2, I've trashed all the code, and we're going to start fresh. So we are reading compressed into a thing. Actually, wait. Let's just leave this code here, because that code's at least fine. Done. So what we want to store from this is we want to know file names, and this will also be the order they appear. Free blocks and file size. Cool. So don't give up on Bash. Don't worry, I won't ever give up on Bash. But man, if I was in a different language, I would structure this so much more. It's so different. If we are even, then blocks, otherwise free space. Index is num divided by 2. And then we can say, so if we are here, we know we are dealing with a block of data. So file names plus equal the number that's there. Actually, wait, we could just do this. No, that's not right. The index is the file name, isn't it? Yeah, the index is the file name for now, and we're going to rearrange them. That's a little bit confusing. Index is the file name. The file size is the number. And the free blocks is what comes after it. The free blocks at index is also the number. This is so confusing, but let's give ourselves some functions. Let's say, print file. We give it an index, and then with that index, we can know everything about it. We can know name, file names at I. We can know size, and we can know free, how much space is free after it. So free blocks and file size. Now we could say something like echo file index idx, name equals name, size equals size, free after equals free. We can do that. So now we have a nice little print file. So we could do print file 0 at the end of this. Part 2, read in from example input, and we can get a syntax error. Vim part 2. What is my problem here? Oh, I used I in IDX, didn't I? That's why. Try to be consistent with your naming. Let's see. You could fake it with an associative array with indexes like file number, free blocks, file number. You could. Yeah. You totally could. It's all about faking things with the associative arrays in Bash. I just tried a 28 GG in there. Cannot assign list to array member. Why am I trying to assign a list to it? Oh, yeah, wait, why did I do this? We're using direct access notation. We don't need any of this stuff. What was I thinking? Oh my god. Brain's getting fried here. Reading data. Okay, so the file at index 0 has a name 0, size 0, and has free space after it. Is that right? The file at index 0 should have 3 free spaces after it. It should have the name 2. No, it should have the name 0, and it should have a size of 2. Okay, so none of that is right. Neato. Why is this not right? Let's see. Okay. What am I doing here? What am I doing here? I'm just doing everything wrong. Man, my brain must be fried. I think I'm done after this one. But we'll get it. We will get this one. Yeah, wow. My brain is completely fried. I'm just using all the wrong variable names. Okay. Yep, and free blocks might be unset if we are at the last one. Cool. So this works. This actually works. That's crazy. So print file, let's print file 0, 1, 2, and we'll just like look at it and see. Cool. So we can see that index 0, the size is 2, the name is 0, and there's 3 free spaces after it. That looks right. At index 1, the name is 1, the size is 3, and there are 3 free after it. Okay, this all looks right. Yeah. So we are successfully representing this correctly. So now we have a good representation of the data. The free blocks will be empty for the last file that's in there, and num files will be the length of file names. That's good enough. Okay, so now we know how many files there are, so we need to loop over each file backwards. That's what we need to do. For I equals, let's say, length equals file names. Cool. I equals len. Let's do len. I have to learn to be consistent. Len minus 1. I greater than equals 0. I minus minus. Do. Done. Let's say we need to try and make this go as left as possible. Try to move this block as far left as possible. And the way we do that is we loop over everything in the correct order. For j equals 0, j less than, j less than I, cool, j plus plus, do, done, cool. So now what we try to do is we started at the beginning to see if there's a spot for I. So we're going to look to see if there's a spot for I. The way we do this is we know our size, let's say current size equals file size of I. That's the current size of the file I. If, let's see, free space equals free blocks at j. That's how much j can offer in terms of its free space. If cur size is less than or equal to free space, then we can move it there. Now we have to come up with the logic to actually move this stupid block around. It's going to be so annoying. We're going to have to do a lot of variable manipulation. So the way we will handle this, we will have to take the thing we're moving, which is I. We are moving I to J. I moves in front of J. This is annoying because we'll have to re-index the whole array. Yeah, we will. And then if we re-index the whole array, these loops stop working. We'll have to do this in a function breakout and put it in a loop. That's what we'll have to do. Yeah. Because we have I, we need to move it to after J. So, yeah. I will become... moves in front of J. That should be after. After J. Yeah, you said in the chat, yeah. After J. Cool. Let's worry about this and then figure out the rest of it later. So, if we're going to move I after J, we have to do a lot of stuff here. We have to re-index all of the arrays. This is going to suck. And the way you re-index them is in bash. That's why the single quote blocks would have probably been more convenient. Oh yeah, exactly. If I could just have a linked list of blocks and I could just move them, my life would be so much easier. I would create another array for telling where what needs to move and then make all changes at the end of J loop. Let's figure out how to, because in order to move something in an array in bash, we're not really, like, we're not moving it. We can recreate the whole array. But we could also just move it. Because I could do something like, let me think. I'm just going to write some code out and we'll see what makes sense. File names at I. File names at J becomes... file names at I becomes file names J. I could abstract this out into a swap function, but like, who cares? And then file names at J becomes temp. But there is work that needs to happen before we can swap them. But this is what all the swap stuff looks like. Kids, don't use bash. Okay. Okay, swap everything. Yikes. So now that we're here, before we can swap things, though, we should update some values. So what values need to update? Well, the free blocks at the free blocks that come after God, this sucks. Let me think. I have to think about this. We have to update the free blocks. We have to keep track of what comes after. So the free blocks at the thing we just moved needs to be actually added to. The free blocks of the thing that we are moving in front of you. Let me think about this. So J is what we're moving in front of. We need to subtract the cur size. Yeah, because those are no longer free. We've taken up those blocks. The free blocks at J will subtract equal cur size. The free blocks at I will now be set to whatever the cur size was. No, the free blocks at J, I'm wrong about this. Free blocks at J become 0. And the free blocks at I become the cur size minus what was there before. Let me think about this. I hate this. I would rather just have a struct that defines all these things. It'd be so much cleaner. J is what we are moving in front of. J is what we were moving in front of. So its free space is going to go down, and it's going to go down to 0. J is going to become 0. It has no free space at all because we've moved something in front of it. The free space that now to the block we just moved it to, this one's easy because the free space is now whatever it was before, which was cur size. No, it was free space minus cur size. That's what we're doing. So what the original free space was minus the size of the current thing because we moved it in front of it. That's what's happening now. And then we have to go through and do the swaps, and then the yeah, we should be fine now because now we swap the file names, the file size, and this. And now that we've done the swaps, we can break out of this loop because there's no reason to process the rest of them. None of the loop sizes have changed. I think we're done. I think we're done. Oh, man. Let's see. So if we're done here, we need to create the checksum. And the checksum is... How do we represent this in a way that can be the checksum? The checksum was just the order of the file names, right? Yeah, we don't care about the file. Yeah, just the order of the file names for the checksum. I have no idea if this is going to work. Yeah, so those are all the file names that we were able to put them in the right order. Nope, I have no idea what I'm printing. I have a bunch of data now moved around, and I don't even know how to represent it. So let me think about this. I don't think you have to swap file blocks now. I think you're right. I don't think I need to swap them. I think I just need to point to them in a different order because the file names order has been updated, right? I think do I just update file names? This can't be right. Let me think about this. Okay. Trying to move 9 after 0. 9 has a size 2. And 0 has a size 2, but it has 3 free spots after. So that should have succeeded. So that should have succeeded. And it did. Now we're going to try to move 8 after 0. 8 has a name of whatever. This should still be the same. Oh, we have to move it to after. We have to move it to after, not take over the block. So free blocks at J is equal to 0. Free blocks at I is the new free size. Now we have to move them. So I think we can just do... No, we're moving it after. And this will mess up the loop because we're using I up here. So this is really cringe. Did you say that? I don't know. I might have just ignored it. What did I do? Oh. I think we're in a loop. Like an infinite loop. How do we even get in here? There's no way that's legit. I minus. Yeah, look at me. Look at me, huh? Beautiful. Thank you. Cool. So now we have this. We're not even printing it out properly to actually be checksummed, I'm realizing. Because we need to print the file name size times and then dot free space times after. Okay. So for... Let's just use this. For I equals 0, I less than, so like just a len variable. I did use len, okay. Len, I plus plus, done. I've already written this logic before, so let's just use it. We have the name, the size, the free. Okay. So now in order to get the checksum, we will do yeah, that's what we'll do. Okay. So for j equals 0, j less than size j plus plus do can I just do this? Let's just do this and let's just see if it works. Okay. All right, so that's what it thinks the final thing looks like. And this doesn't look anything at all like what's happening over here. So I'm doing something wrong. Let's see. How did you delete all the words local just now? Control V. V is select. And you can just use V and then you just move left and right to select things. Shift V will do entire lines, and then Control V will do a block style selection. So I'm just going up and down and left and right. You do this, and then if you don't want those things to be anymore, just hit X, and then they're gone. Yeah, that's how I do it. So somehow this thing managed to fit 888 at the beginning of it. That doesn't make any sense. Let's do this. We're going to put this in a function called print all. This will just be for debugging purposes. So what we can do is we can go at the bottom of this, we can print all and exit. And before we even get started, we can print all, and then we can see what it changed. Yeah, no problem. All right, so here's what we started with. And let me double check over here. It looks like it's basically the same. Yes, it is identical. We have this perfectly. Cool. And then after the first movement, we take this 99 and we get rid of the 00. So that's not right. That's not right at all. So we're doing something wrong. Let's see what's going on here. So we exit out of the first one. That's fine. We try to move I, which is the 99, to after J, which is 0. And it should work because 9 has a size of 2 and J has 3 free spots. Cool. So 0 has 3 free spots that come after it. Because we know that, we set the free blocks of J equal to 0 because that is what we're trying to move. That's not right. And we set the free blocks of I, which is... No. Wait. J is what we're moving. No, I is what we're moving, and J is where we're moving to. Yeah, J is where we're moving to. So if we're moving to J, we have to set the free blocks of that to 0. And then we have to do... We set these and then we swap. Yeah, that's not right. We set these and then we swap. I'm still thinking about structures. Something is wrong at the free space logic. We shouldn't switch I and J. Setup. Yes. Yeah. Yep. Yeah. That's what's going on here. We swap them, and that's beautiful. So now that we're swapped, now that we are swapped and we live in this world where J is what we're moving. So now in this world where we swapped, I is what we're moving and J is where we move to. So where we move to... Nope, confusing myself. I guess we can just do it up here before we even swap. So before we even swap them, we're going to set the free space to the thing that we're moving to. I think this is right. Let's just try it. Yeah, that wasn't right. That's what I get for just trying things. I see what's going on though. Like I can see the way that it's manifested what's wrong. Because we swapped everything. We swapped the file sizes don't change. The file names don't change. We're just swapping them. So now this is working. We're swapping out what is 1 and what is 999. Oh yeah, that's not right. That's not right. Yeah, we can't just swap it out. We'd have to swap out everything. We can't just swap it out. That doesn't make sense. Yeah. No, we have to make room for it. We can't just swap it out. Yeah, we have to insert into a given spot in the array, and we can't do it. All right. I'm gonna lock in, and we're gonna do this right. So we have the place that we just checked, and we have the thing that we want to move. We want to move J, and we want to move it to be after I. So in order to move it to be after I, we have to updates I free space. Yep. If we're updating it to be after I, we have to change it to whatever its free space was, and then subtract the current size. No, none of this is right. Oh, this sucks. Man, I might be getting to the point where I have to reach for a different language. This is just not how I would think to approach this problem. This is so backwards to how I think. So we know J needs to move to be after I. So that means I's free space is going to go down by whatever it already was. Why did I get free space here? Oh, J's the beginning. I'm so backwards. I'm so not good. Yeah. J is the beginning, so I is the thing we're moving. I don't know. Yeah, I had this right. Yeah, so J suddenly has 0 free space because we're going to push something up against it. I has the free space of what J used to have minus the current size of the thing that we're moving. And now we have to move. We have to move J in front of it. We have to move I in front of J. We're not going to use temp variables to do it because we're not swapping. We have to recreate the whole array. We have to create a new array that takes what was in the array at the beginning, has to take what was in the array at the end, and everything in the middle. Dude, this sucks. This sucks. I don't know if I can do this in Bash. I'm gonna be honest. I mean, we've been here for over 3 hours. It's tough because we're so close, you know? Because like this needs to be 0 to J. So if J spot 2, we're actually not moving J. So J plus 1. And then this needs to, I don't think I can do this in Bash, guys. I'm going to be honest. I have no idea how I would even approach this problem. Well, I do know how I'd approach it. It just doesn't fit with the way this scripting works. I'm going to try and think of other possible solutions. I'm going to try and think of other solutions in Bash before I give up on this. Okay, I give up. I'm calling it here for Bash, and we are going to do this like big boys. Y'all ready? We are going to do cargo, new, Rust, part 2. Buckle up, we're getting into Rust. Generate real files. I thought about that, like just literally generating actual files that have like sizes and stuff. But I'm done here. We're doing it in Rust. We're doing it like big boys. That's what's happening here. Okay. Okay, let's go. So now we can do what is it? Is it example input.txt? Yeah, I think so. Okay, got that. Now we can do a nice little, is there like a .chars method? I think there is a .chars method, right? For C in input.trim.chars.enumerate. Cool, looks right. Now we can say if I modular divided by 2 equals 0, then even, else, what are you saying? Here doc, generate files that execute that tells what its size is, and free space using string substitution for altering. You have to keep track of the order somehow. That's my only problem, is how do you keep track of the order? Because like the file names are kind of embedded in that. You'd have to store the file name as a piece of metadata. But I mean, if you have a solution that you think will work, write it out, because I'm giving up on it. I'm totally just giving up on the Bash solution. And maybe that's my fault, because I've done work similar to this in other languages, and Bash is just not fit for this job, man. It's brutal. What do we want? You want the index, and okay. So the even number will always be first, and does everybody loop over 2 jars? Now that you gave up on Bash on this day, I must try this one. Oh, you absolutely have to. I would love for you to do that. I think that'd be super fun. Let's see. Let blocks equal. Let's just store the input that we read from the file. Okay. So now we have free and we have blocks. Cool. Oh, YSAP leaderboard. That'd be fun. I like that idea. So that doesn't do anything. Cool. That's what I thought. So now we can do a... cool. Let free equal, or let f equal free at spot I. Well, let me take it from it. It's clone, right? I think it is. Gotta call iter on it. Yeah, that makes sense. 0 to 1, 1 to 2, 2 to 3, 3 to null. Then if 3 gets moved to the right of 0, it'd be 0 to 3, 1 to 2, 2 to null, 3 to 2. Right, yeah, no, I understand the concept of a linked list. How are you saying to store this? I'm gonna be honest, I don't quite understand how to, Micah, I don't quite understand. Hold on, my brain is fried. I have to lock in to read what you're saying. Give me a second. Oh. Could you fake a linked list by maintaining an array of what the next file is? Order is just another array that points to the next file. 0 to 1, 1 to 2, 2 to 3, 3 to null. Then if 3 gets moved to the right of 0, it'd be 0 to 3. Right, so I'd have to change the order. Right, and then you're just like swapping them out. That makes sense. Keep the next file name in an array, and the index of the arrays is just the file names. Right, so I have an array of file names, and the index of it, or sorry, the index is the file name, and the value it points to is what file comes after it. That makes sense. I do need to know what file comes after it, because here's the thing. I don't know if this accounts for this, but like when I move a file, here, I'll visualize it. When I take this file like 99 and move it here, I have to consider this the new layout of it now when I go back and regenerate where things fit. I think that fits in with what you're saying. Let me see. Let me see. I think you're onto something. Yeah. Next file, free blocks after, and file size. I think that's what I was attempting to do with file names, because why would I store file names? Why would I store file names? Because the name of the file is the index. You're right. I know. That's why I'm wondering why I was storing file names. I feel like I was onto this idea, but I just didn't quite flesh it out. You're right, though. You're right. I'd have really lock in to focus on what you were saying. Yeah. Instead of file names, I don't need that. We just need next file. I'll have to change that, but that's fine. Let me just do this and let me think about this. Because it's late and you've been live streaming for hours. That is the answer. I don't know if you guys know this about me. I talk about it often on my channel, but like, people are like, oh man, I love getting locked into those 8-hour coding sessions. I'm like, bro, I don't do anything for more than like an hour. Like I get burned out and then I'm done. Like, you got to take breaks. Like, I'm a bad example of what you should be doing. Don't do this. Or this hopefully is a good example of how stupid I'm thinking. But no, you're onto something. You're not onto something. You're on it. Yeah. this is it. Like, you're right. I think this is all I need. I think you're right. Yeah, because I just need to traverse the list of next files to loop over them instead of the length. Let me think about this. So the next file at index 0 is always going to be, so when we're creating these, we know that the next file is always going to be the IDX plus 1. Like, if we're at file 0, we know the next file will be file 1. We don't even have to do that. We just need to check if it's the last one that we have to set it equal to, like, null or something. So what we could do is, if we're down here, we could say next file IDX minus 1 equals null. Is this valid syntax? I don't even know if this is valid syntax, but, like, you know what I'm trying to say. I think that's right. And then for print all, instead of looping through that array, we're going to just basically do, or 0, because nothing should be to the left of 0. Well, no, the next file, no, you're right. Yeah, because 0 starts at the beginning. 0 is you're right. 0 is a good sentinel value because nothing can actually ever be to the left of 0. Assuming they always increment like that. Wait, no, yeah, we index them. You're right. So now we just need to loop over linked lists, which I've done before a million times. So oh my God, local next file, or let's just call it pointer. Oh, wow. Yeah, this is making me think of C. This is so much easier. Next file at 0, because that's where we're going to start. Next file equals 0. The pointer is that at next file. And then we can do while, I don't know. I'll think about what goes in this while loop, but while true, do. And now that we're in here, we know the cur. Let's just keep it as I. We've now got it in at that space. Cool. So now, in order to figure out where to go next, we have to grab next file at I, because that will point us to the next place we have to go. So that would be the next file at I, points us to where we need to go next. And if while next file not equal null. I'm just gonna leave it as null for now to make it easier for debugging. Next file equals that. And now that we're here, yeah. I think you're right. Yeah. I think we're onto something. Oh, man. What is this chat message? Still trying and started hallucinating. Why is that chat message in blue? That's wild. I don't know what that means. But thank you for the fancy message. How'd you make that happen? Well, you didn't pay me money, did you? I don't know how to check that. I've been streaming for 3.5 hours. Holy God. That's crazy. Oh, wow. You actually paid real money to send that message? Yo, thank you. I appreciate it, man. That's awesome. That's super cool. I've never had anyone send money over YouTube before, so I didn't know what that meant. Yo, appreciate it, man. That's awesome. That's crazy. I didn't know what that message was. I didn't know why it was blue. That's crazy. Yo, thank you, brother, man. Appreciate it. All right, let's see. Yo, Davey, you cheersing tonight or nah? Bro, I don't even know what that means. Let's see. Next file is whatever next file is at 0. We always start at that index because it should never move. And then whatever the value of that is, that becomes the index that we feed it back into. Okay. Okay. All right. And that's how we print all. Real input. No, not real input. Example input. Well, that's probably not great. Part 2. Brain is fried, everyone. Did this not get set? Let's just see what all the next files are sent to. What is this 10 here? Okay. Okay. You know what? I think it's my fault. I think I'm off by 1. Okay. Okay. Let me look at the chat real quick. Oh my God. Guys, super chat message. We love your content. Just subscribe already. Yo, thank you for the message. I appreciate it. Yeah, if you're watching, you like this content, go ahead and hit subscribe. It's free. It doesn't cost you anything. You don't have to pay to send me messages. All right. Please don't feel like you have to. But if you want to, obviously, it's much appreciated. That's super fun. That's super cool. I've never gotten super chats before. So look at me. I'm like a real streamer. Oh, man. Yo, greetings from Poland. Yo, dude, welcome, man. Glad you're here. Let's see. Okay. Trying to move 9 after 0. Success. And then we break out of the success. So now that we have that, we have next file, we have free blocks, and we have file size. Only thing that ever needs to change are our free blocks. We need to update them. And we need to set the next blocks. Next blocks? Next file. And we need to update the next file of the two things. So the thing that we are moving, J is what we are moving. We're moving it. So the next file is set to whatever the next file of I was. And the next file of I is set equal to J. I have to think about this more. I'll think about this more because we're having to touch indexes and not values. We're not looping. We're not doing this right. I gotta think about this more. Oh man, what are we doing here? We are looping through the files forwards and backwards, but we can't just do this. We can't just do this because we now have a linked list of things that's keeping track of the order. So when we loop this, we have to loop in order. This is, yeah, see, this might be hard. Yeah, I agree. Give me a minute. I'm going to take a little break. I'm just going to go grab something to drink. I'll be back in 1 minute. All right, I'm back. Yeah. Oh, man. Let me think about this. How do I want to do this? Because if we move something, we update that linked list. But that means when we loop over it, we have to loop over it in the order of the linked list. That might not be hard. No, it will be. Yeah, because we've abstracted the order. And we can't really do that without consequence. I don't need a doubly linked list. I mean, we can just use a singly linked list. It's not a problem because I can just iterate over it. I don't care about performance yet. Yeah, when you make a change, you have to move across the new list, and that's where it gets, like, difficult. I have an idea. Listen, man, you can say it all you want. I'm never going to ask ChatGPT to solve a problem for me, all right? What do I want to say here? I'm just not going to say anything. I'm just not going to ask ChatGPT to solve anything for me. That's how I feel about that. I have an idea. Once we generate what the new order should be, generate all new arrays. just regenerate all new arrays. Create new temporary arrays and just copy them over. Oh my god, this sucks. There has to be a better way to do this. Yeah, because we need a way to specify order, and a linked list is a really good way of doing that. So we have this linked list, and we have the ability to loop over the linked lists. And because we have the ability to loop over linked lists, we have the ability of resetting these three things. I think we need 4 things. I think we do need file names. Because the index will change of these. I think we need file names. We need 4 things. I mean, basically what we're doing is we're having a struct with 4 items, and we're storing them in an array, but because Bash we can't do it, we have to just have 4 arrays of just really basic data. So now that we are here, we're going to move it after. Yeah, we can move I moves after J, and the way that we accomplish that is by saying the next file at I, because I is the thing at the end, will become whatever the next file at J was. Because J was the no. I is the thing at the end, J is the place that we're moving. Yeah, so whatever it was, that becomes that. The next file at J becomes I. I have to think about this logic. 2:30 a.m. question. One more beer or coffee and food, sleep or waking up? What is your question? I don't know what you're asking me. You asked me what my drink of choice is? Pepsi. What my alcoholic drink of choice is? Captain and Coke. Keep it classy. Oh, man, this sucks. All right. Whatever was... We do need a doubly linked list, because how do we know what the thing at the end was? How do we know how to nullify the thing at the end? This is so annoying. Although I guess if we're going to retain order after every single one, then whatever's at the end whatever's at the end will just always be null. I think we're on to something. Man. Now we need to recreate all arrays. Oh, my friends, this is wild. Local new free blocks. We're going to create all new arrays here. And then okay. So now we've created all new arrays, so we can set the existing arrays to these. So after every change, we're going to recreate the arrays with indexes 0 to whatever it should be. Trying to move 9 after 0. Success. Bro, I don't even know what it's printing anymore. I'm printing out the next files, aren't I? What does print all do? Well, this doesn't work, does it? Go for a walk is some of the best advice, honestly. I need to take a break from this. But I'm so into it now. I'm revitalized. I want to know what's going on here. I think my print all function is bad. Oh. Well, that'll do it. Try to use the right variable names. There we go. Okay. That is what the first puzzle looks like. And then we try to move. I print a success at some point. Hey again, you managed to do all previous days in Bash? I have. Why is it not printalling twice? Why am I not getting here? I am getting there. Print all is just blank now. Okay, well that's clearly wrong. I think probably this is going to be messing up something somewhere. Yep. Have a good time at work. Thank you for stopping in. Let's give me something about this. Let's look at all the next files. Oh, that seems wrong. Just the string I got in there. How did the string of I get in there? Oh, that'll do it. Okay. I'm doing something way wrong here. Okay. If we found a place we can move it, then J is the place we're going to move it to, so it no longer has free space. I is going to have its free space removed from whatever it used to be to its own size. Cool. We have to update some next file. These are our pointers. So our new order will say that whatever was at I, which was the thing to the right, this was the thing that was all the way to the right, its next file will be whatever J's next file was. J's next file will be I think this stays here. I don't think we do anything here. And now null points to 1. Yeah, that's wrong. Why is there a key in there named null? How did that happen? How do we get a key named null? Where did that come from? Yeah, 0 and 9. Okay. That's the only place I'm printing it with a colon. So A, one of the keys of the next file array is being set to null, which I don't even know how that's possible. Because it should just be set to 0. How is a key being set to null? Where are we feeding in the word null as a key? How does this even make sense? Where are we getting that crazy null from? It's here, right? I'm not crazy. It is there. We have a key named null. We are going to figure out where this null value comes from. We're going to use the PR command that I used in the previous day's challenge. This is a way to print an array. PARR. We're going to bring it in. We're going to source it. And we're going to figure out what's happening here. That looks right. Cool. That looks wrong. Okay, so it's being set somewhere above here. Somewhere above here, we're messing something up. Yeah, right there. How are we doing that? Oh, I'm looking at the wrong output. I'm so stupid. Somehow 9 points to 10. I mean, that's wrong. Minus 9 point to 10. Okay. That's because I put it up there. Okay. Okay. Okay, we're still right here. We are still right. We're still right there. Okay. The array is right every time. Then how do we get that? Where does this even come from? What? Where does that even come from? Am I just... you know what? There's variable leakage. Is that what's happening here? I mean, it's totally possible that we have variable leakage because we're using J's in here. Oh man, that might be it. That could totally be it. Okay, we have one null in there. Oh, that's not right. We shouldn't have that one null in there. Unless we're looping over the values. Yeah, we're not looping over the indexes. Okay, I'm just doing everything wrong, aren't I? That looks way better. Way better. Okay. Okay, I see what's happening. One, two, three, four, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. At no point did that ever change. I appreciate that hint, but man, I've been doing WQ for almost 20 years. I don't know if I could unlearn that. I'm going to be real with you. Am I crazy? I'm literally modifying it right here. Okay, well, my modifications are working. I do not understand. Are I and J the same? No, they can't be. Yeah, we're trying to move this one to this one. Love your content, man. Cheers from Argentina. Yo, thank you. Appreciate it. Nine to 0. Yeah, that makes sense. So now 0 should point to what's at spot 9. 0 is J. So J should point to what's at 9, which is I, right? Yeah. And yeah, this is wrong. Nine should point to 1. And then we need to figure out where the null is. The null would just be the last item in the array. No. The null would be the thing that... God, this sucks. We have to figure out what points at the thing we're moving. So we have to figure out what points at I. No, we have to get to the end of the list. We have to hop the list and get to the end. I know a way to do this. That's super janky. But I know a way that's super janky. That's how we do it. We don't even bother checking null. We literally just do this. This sucks, but I don't care. Yeah, that way we're just not even gonna care what null is. Because we're just gonna chop it off at the end. Okay. Okay. Why not open a new terminal tab window so you don't need to keep closing and opening Vim? I mean, just I press keys on the keyboard to switch tabs or switch Vim. Like, I don't know. I just like working in one terminal. It's easy. There's going to be something so obvious that I'm missing here. It's almost like comical. When I recreate all arrays, what do I have for file names? I have nothing. I do like using multiple tabs to retain the undo history in Vim. Yeah, I could see that. I don't think about it. Okay. Do we even have size? We do have size. We just don't have names? Did I not copy over names? I made a new array, right? No, I did. Oh, well, it'd help if I named the variable correctly. This is going to be... I don't even want to edit this video. It's going to be so brutal. Well, that's not right. Not even close to right. Oh my god. I really don't even want... I'll give it like 30 more minutes, but then I'm gonna have to call it. Like, I'm so over this. Okay. That should not happen. This should not happen. But we'll see. Well, it did try to move the 9-9. And also attempted to leave it in the same spot. So that's not right. When we recreate all arrays, we don't create the next files. We have to reinitialize the next files. That's what we have to do. Yep, so when we get down here, we have to do next files equals this. It's +1, right? If we print all, and they're all in the correct thing, we don't need to use the next file thing because we've already recreated all the arrays. Let's just do this. So file names has the same value stored in there twice. Okay. Nine points to 1, 1 points to 2, 2 points to 3, 3 points to 4, 4 points to 5, 5 points to 6, 6 points to 7, 7 points to 8, 8 points to 9, 9 points to 1. And I think this last one gets thrown out, right? Because we've moved on. Yeah, I don't think we do work on that last one. We don't. Okay. Why does 8 still point to 9? Oh. Because it's now at the end of the array. Right. So when we get down here, yeah, then they all go up by 1. It would help if I called them the same name. Oh, man. Okay, well, we've duplicated 9. We've overwritten 0, so that sucks. Why is that happening? Okay. Adding 9, adding 1, adding 2. Yeah. Okay, this isn't right. Yeah, so I think it's just this logic to move things here is being messed up. Let's see. Hey, we're moving it after J, right? I can move after J. Yeah, we're supposed to move it after J. After J. No. Yeah, so in order to do that, J will have a free space of 0. I will have a free space of that. Yep. And then we have to just swap them. So 9 and 0 get swapped. That makes sense. Not swapped. The next file of J, which is at 0, will become $I. Yep, it's the thing that's there. Which means the next thing of $I will become whatever's directly after it. Whatever's at J plus 1. Yep. And then the next file of J is the beginning, become 9. The next file of 9 will become 1. That's right. And then the recreate all arrays uses the NF logic here. And we don't ever use that variable I. I can't see how this is wrong. Oh my god. Yo, what's up, Ashcop? Yeah, we're on part 2. I've been streaming for almost 4 hours. I want to die. I cannot get this to save my life. I got really frustrated, and I was like, I'm just going to write this in Rust. And it'd be so much easier to write this in Rust because it's basically like memory paging. I've written like an alligator before in Rust, in C. It sounds impressive. It's not. Basically, basic stuff. And I know how I want to architect it, but in Bash, there's no good way to architect it. So instead, I have like 5 arrays, each holding different pieces of data. And I have this like pseudo linked list thing going on. And I'm in way too deep. I've been on this too long. I should just quit. But I'm stubborn. So here we are. That's where we are. All right. Let's see. Oh, we're in so deep. I should add structs. I mean, it'd be awesome. So I don't see... Listen, advent of code. So I have 9s at the beginning and I have 9s at the end. Like, just let it slide, man. Like, come on. You know what I mean? Like, who cares? Like, they fit. Somehow I'm just losing the 0. Like, if I just had the 0s at the beginning and I've just lost track of where the 0s are. Yeah. I've just completely lost track of where the 0s are. And I don't even know how. Yours is incredibly slow? Oh, man. When I'm done with this, assuming I finish it, I'm definitely going to look at your solution. I want to see how you knocked it out. That's why my wife hates Advent of Code. I fall down the rabbit hole every year. Well, listen, man, there's a cheat code for that. It's called Be a Single Guy. Oh, man. What's up, ladies? Who likes bash? I shouldn't even joke about that. I get, like, on Instagram, because I have a ton of followers over there, I will get creepy DMs from girls, actually, believe it or not, and guys. I mean, really, there seems to be no gender for creeps, but I will get some unhinged DMs like, we're in love, we're supposed to be married, blah, 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 blah. I know you're talking to me, and I'm like, dude, like, I'm never responding to this. That's crazy. Just fix the zeros at the end, easy. Dude, honestly, skill issue on my part, seriously. Like, yeah, agreed. Like, just code better. J less than equal 0? Where do I have that? I don't even know where that is. That might happen if I keep doing AOC challenges. Oh no, that's not what I meant. That wasn't what I meant. I'm sorry. Oh man. I should mean after it runs, put the zeros back. Oh, right, no. That looks great to me. Bash Cop, what do you think? Ship it? Oh my god, I'm losing my mind. I've been at this for too long. Okay. Yeah, file names at I think it's my logic to recreate the arrays. I have to be doing something funky here. I am doing something. I'm stupid. Sleep on it and try another time? What do you think? I'm like a responsible adult? There's no responsibility here. Oh my god, when I'm done with this, I'm just about to go over there and play some StarCraft 2, so it's not like I got anything else going on. Oh my god! That looks right. I mean, there's missing periods at the end. Oh, because I didn't update the free space after 8.8. But I don't think that matters. I don't think that matters because we don't use those. We don't use those to check the checksum. Oh my god. Yo, let's go. Let's go. Oh my god. I'm just thinking about what my life has become. All right, we're good. Lock in. We got this. Oh my god, when I clap, it looks like I'm clipping my mic. Let me know if that sounds distorted and terrible. Wait, what? Hold on. Something's going wrong here. Somewhere I'm printing without new lines, but you know what? We're making progress. So who cares? I do. I care. Where am I? Where am I lacking new lines where I print? I do print out. I know I have echo dash ends there. Oh. Is this where I just do a final print of it? I don't think I need this. I don't think I need this. Oh, Matt, you were asking how I comment things out. I'm going to show you a way that I've commented things out in Bash, which is super cringe. Ready? There we go. Now that whole section's commented out. I put it in a function that I'm not going to execute. Okay. Okay, let me get rid of that. This looks wrong. No. Wait, 2111777. But then all these are wrong. All these are wrong. Okay. But we're like kind of right. You know what I mean? Like advent of code. I'm like kind of on the right track. So like, go ahead and just give it to me. I can't do this. Less. There we go. Okay. There are 7s there. And also the 7s are still in place. So at some point, things are being lost. But we're making progress, which is insane. I'm going to cut out the amount of debugging I do. Okay. So we move the 9s. The 9s successfully moved. Now it says we move the 8s, but that's not. We should not have been able to move the 8s. Instead, we move the 7s. And we move the 7s into the correct spot. But the problem is we somehow just lost track of the 8s and kept the 7s in the process. So there's going to be some little sneaky little detail down here that we're not quite doing right. J is equal to 0, J is less than I, J plus plus, and I starts at the top, and then we work our way down. This makes sense. Just tuned in. It's so relaxing to see the person with a lot more experience print debugging just like I do. Listen, man. Listen, man. You will take my echo and my printfs and my print debugging from my cold, dead hands, I swear. I love tools that exist. Rust has tracing. I'm on an operating system with dtrace. We have MDB for postmortem debugging. I love all these tools so much, and I love printing the standard out. Yo, set minus X is so great, though. Oh my god. I will bash minus X so many things. That's a really easy way to find like performance issues. Doesn't mean you can fix them, but yeah, no, bash minus X or set minus X, wonderful. Oh my god. All right. So what's happening here? This is where we discover that we can move the 777. And we do move the 777. We put it here. But we also leave it at the end, and we've lost track of the 888. So how have we lost track of the 888? We can do some debugging. For instance, this len. We take the len of the next file. And then we recreate next file based on the len of the file names. And the file names is whatever the new files is. Man. Okay. Let's do this. Here's what we're going to do. Does it matter that I haven't initialized this? Free blocks at index equals 0. Like there's nothing free at the end. I am just kind of treating it like it's 0. I don't know what's happening. Maybe you need a return versus break like your code review. Hey, someone watches the code reviews. Except when you save the output of a function from an echo, set minus X screws that up. Does it? I would assume set minus X would go to standard error. I don't think it would affect that. I mean, unless you're doing some weird redirection stuff. I wouldn't even think that your script can capture that stuff. Because I know that xtrace, you'd have to follow that, and you can customize your own function, and the PS4 variable gets used for the prompt. I'd have to look into that, but I don't think it would do anything weird like that. Here's what we'll do. Get the length of all these, because I don't trust anything. So free blocks has a length of 9 there. Did we set it to 0 now? Okay, now they all have a length of 10. Awesome. Will they all have a length of 10 after we recreate all of them over and over again? They do. They always have a length of 10. Okay, good. Okay, so we determined that the 777 can move over. We don't remove the 777, but we do remove the 888. So I'll have to figure that out. All right, 0 points to 1, 1 points to 2, 2 points to 3, 4 points to 9, 9 points to 5, 5 points to 6, 6 points to 7, 7 points to 8, and 8 points to 9. We throw out the last one. 2 points to 8, 8 points to 3. Okay, yeah, no, this makes sense. All this logic is sound, but how are we losing data? That's what I want to know. It could just be the print all function is bad. We want file names at I, we want file size at 9, and we want free blocks at I. Nice. That's weird looking syntax. I quoted that wrong, but it's going to look like how I want it to. No, it's not. It's going to think I'm trying to make like some sort of array or something. This is what I wanted. Oh, did I put dash I? I'm dumb. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, somehow 9 is set to 777 and 3 is set to 777. How did that happen? How did names linked list bash? It really is. Like, we're literally making a linked list. And like I said, I might do this because I went through and did day 6 in Rust. I might go through this and do this in C in my own time and then come back and show you guys the solution. Like, this is how C should be. It should be a linked list of structs, and the struct should know how big I am, what my name is, and how much free space I have next to me, and that's all the linked list should know. This is, I mean, I've written code like this before. This is basic system stuff, but Bash is not suited for this. I'm only angry because I can't express quickly in this what I could in a language like C. That's what's going on there. So when I recreate all arrays, if I do a printf, if we print out all the names that we have, we shall see if something gets messed up or when something gets messed up. 091727. There we go. Those file names are wrong. You just gotta embrace strings as structs. You know what? I'm embarrassed to say that I've been thrown so far around in many directions. I should have just done that. Like Bashcop, you're right. Literally, I could have just made an array, and inside the array, I could have put in name pipe, free space pipe this, pipe that, and then just broke it out when I needed it, separated by the pipe character. Like, yeah, you're actually absolutely right. Bash cop. Oh my god. From now on, you're gonna have to be present at all of my streams, and you're gonna have to just like make sure I lock in and like do the right thing. And by the right thing, I mean clearly the wrong thing. Treat everything like a string. Although in Bash, everything is a string basically. So, yeah. Yo, what's up? Welcome to the stream. Let's see, what do we got going on here? All right, so this is where we move 7 down here. Before 091723456 0191727. Okay, so the new thing we've generated has a duplicate in it. This is the problem. So the new file names have an issue. So that means the linked list is pointing somewhere back to itself. 723, 727. 4 points to 9, but 9 points to 5, 5 points to 6, 6 points to 7, 7 points to 8, and 8 points to 9. That looks fine to me. Yeah, we have 7 here twice. We have 7 here once. It's at the bottom, but it doesn't matter. And this is how our pointers work. 6.7, 7.8. There's nothing wrong with this. Something I'm doing is wrong. I do think yours is going to run a lot faster, though. Hey, if it ever runs. If it ever runs. It's so bad how slow it is. I don't even remember how fast part 1 ran. Part 1 was so annoying that the checksumming took me longer than it should. Part 1 is really embarrassing how I did it. Oh my god. I can't even explain it. It just took forever. Once I got it right, part 1 ran so fast. I ended up doing the checksumming in awk towards the end just for extra speed, but the bash solution is just fine, actually. But yeah, no, if we ever get this running, we'll see. Printf debugging, let's go. Or echo debugging, I should say. 091727, there's our problem. So the pointers are just messed up. It's going to be where we recreate the pointers, which is here. So we write the free blocks to 0. We write this free blocks. This logic has to be wrong. There's no way around it. This logic has to be wrong. Or missing something. Oh, I think I know what it's missing. But let's think about this first. The next file of J, which is the file that we were looking at, is I. So J now points to I, and I points to what came after J. No, I shouldn't be making assumptions. Well, and this assumption's fine to make. We should be using a temp variable. Or not. Maybe that'll just completely break things. Uh-oh, what have I done? I don't even know what I changed just to cause that to happen. Well, they're all 0s and 9s now, so something's broken. Did I change something down here without realizing it? What did I do? Whatever was at J now points to I. Cool. Whatever was at I now points to the thing after it. J is the one that's 0, so whatever is 0. J now points to 9. 9 now points to J plus 1. Everything else just keep pointing to the same thing. Yeah, thank you. Yeah, I did, because I didn't mean to increment J. Oh my god, I just mean this to be 1. Yes, thank you. Oh my god. You are a lifesaver. Yes, that's what I was doing wrong. Oh my god. Dude, I can't code this long. I'm going blind. I will have to call it soon, whether I get the answer or not. I just really, really, really would like to get it, because it'd be so hype. I know what's happening. Like, I know what's happening, but I can't express it in a way that I could fix it. 7 was able to move, and we only went up to 7. I know what's happening. Yeah, because we need the thing. We need the thing that was before the thing we moved to point to the thing after the thing that we moved. I don't even know how to describe it, man. So if we're moving 7, the 777, I is the 777. We need the thing before I to point to whatever I points to. Plus equals plus 1, not plus equals. Oh my god, don't do the same problem. I think this will work until it doesn't. Okay, well that did nothing. Guys, this is ridiculous. Rewiring this whole thing is so crazy. I don't even know what's happening here. I'm just gonna wing it. I think I'm onto something. Oh, yeah. And when I move something out, I need to increase the free space of that thing now. Because I'm moving it. Oh my god, wait. Okay, it's not right. But it's looking very close to right. Okay, it's not right, but it's looking very close to right. It's looking so much better than it was before. We're losing space somehow, but that's okay. We're supposed to lose space. It's supposed to go down by 2 spots at the end. Some dots have gone missing. Yes. I'm not going to put the dots at the end of the example, and so I should go down by 2 dots. I'm going down by way more than 2 dots. So something is very wrong. But my god, we're making progress. This is fun, right? Right? I'm having fun. I think I'm having fun. Can't tell anymore. I am having fun. I'm just being a jerk. Okay. When you move the 7, you lost a lot of dots. You're right, I did. So let's see. We try to move the 9, and we did move the 9. We're going to try and move the 8. We can't move the 8. Try to move the 7. Hey, we did move the 7. We lost 1 dot. Maybe we are going to have dots at the end. Why did we lose a dot? Yeah, that's wrong. But we move the 7. That's cool. So now that we're here, we tried to move the 8 again. That failed. Tried to move the 8 again. I don't know why we did this twice. Trying to move the 6. That failed. Trying to move the 5. Try to move the 4. Hey, we were able to move the 4, and we replaced it with 1 dot. Why am I replacing it with 1 dot? Where am I increasing the free space of something? Free blocks plus equal the current size. Yeah. What is the current size? The file size that we're trying to move, yeah. I don't know if this is valid, so I'm just going to knock it out. Oh. Sounds like I do need that. Yeah, the 8 didn't move. Everything just shrunk a little bit. What the hell, man? Bro, what is happening? How do I even explain what's... I don't... How did I lose 1 dot? Yeah, this is the free size plus the current size. Yeah. I can't tell what's wrong here. Oh, man. Add 1 seems good. You know what? I love the way you think. It's so chaotic. You are cut out for Bash. How does this look good to you? I just got rid of the 8s and made them all 4s. Oh my god. Yeah, see, when I moved this 44, it replaced it with a single dot. When I removed this 777, either replaced it with 2 or lost some dots or something. It's because the 7 in the middle, because the 7 has free space before and after. You're right. Yeah, so this thing has a free space of 1. And 777 had a free space of 1. And when I replaced it, I just added it here. I didn't retain this free space that 777 had. Yeah. Yeah, you're right. You're right. When we're here, the free space that I had. What am I moving? I is the thing that's moving. The free space that it has, I just wipe out. I just do this too. But I don't want to do it because its free space is important. This code sucks. I free space. Well, then like something there. Wait, times? No. Why did I do that? Ah, good call though. That is it. I'm just doing something really janky here. Free blocks at J of 0. Free blocks of I has to be updated because that's the thing I'm moving. And then the free blocks of the things that came before it needs to get the current size of the thing that's being moved plus how much free space it had. This is valid, right? Ah, frustrating. Does bash minus x go to standard error? It does. And what's a marker I need to look for to find the part of the code I care about? I need to look for 4 dots in a row. What? How is that not a valid pattern? Pattern not found. What? Oh, they're gonna have slashes in the names, aren't they? Oh man. I can't believe you just redirected instead of using that. Listen, that pipe ampersand notation is new to me. I think it's been around since Bash 4, so probably over a decade now, but it's new to me. No, it doesn't even tell me what those values are. Well, let's just get lazy. Echo free blocks at I-1. Echo cur size and echo I free space. Trying to move 7. It was able to move 7. We had 1, 3, and empty. 1, 3, and empty. 1 is right, 3 is right. The other one should be 1. I free space is empty. Okay. Probably because I called it free space, not free blocks. Wow, dude, imagine being so bad at programming. Oh my god, wait. I had it right here, but then when it moved the 8, it somehow just lost track of it. It just did that. That was one of the things I discovered when reading the manual. Oh, that's awesome. My buddy always did it with ZSH, and in my mind I was like, oh, it's a Z shell thing. Like, we don't have that in Bash. But then I was like, wait, no, it does have that. I found that out like years ago, and I was like, oh, I should learn it, and I just haven't. You shouldn't be moving 8 again anyways. Listen, I know. Why is it trying to do that is what I want to know. Because, like, this loop should prevent that from happening. Like, we've already moved beyond 8. We shouldn't be trying to move it again. Why are we trying to move 8? Like, we just lost free space. Like, somehow 8's free space is wrong. Yeah, somehow this thing just changed. Why are we checking 8 again? How did that happen? For I equals len minus 1, I is greater than or equal to 0, I minus minus. We already started that one. Like, we should never go back down. Like, once we move past 8, I don't even know how we get there. Yeah, how are we going back up? We'll have to figure this out. Yeah, I think you maybe need to change the index when you do a move. Oh my god. That can't be it. That can't be it. Whatever I say I'm gonna do, I mean in Minecraft. No, you've got to be kidding me. There's no way. There's no way. There's no way. I'm gonna lose my mind. Woo! Bro. What? Are you kidding me? I'm done, dude. Dude, I'm done. I'm done. What the? I'm gonna lose my mind. I'm losing my mind. This is insane. Oh my god. Never doubted for a second. Bash Cop, you are fantastic, but that makes one of us that never doubted me. Oh my god. What? Everything is global. Unless I use local or declare, I got lazy. I got lazy. That's the moral of the story. I got lazy. That's valid syntax. Don't highlight that red for me. Oh my god. What do we do? Do we just run it against the real input and, like, it's not just gonna work? Oh my god. Oh, it's gonna print a whole bunch of crap, isn't it? Yeah. Let's, do I even have checksumming logic? I don't even think I have the checksumming logic, do I? I think I just have the final thing, which is fine. I'll just save it to a file, so if we do have to reprocess it later, I don't feel like writing the checksum logic. Yeah, because I have the awk script that can go through and checksum it. So I'll check. You know what? Bash Cop, I'm going to message you my final result, and I want you to print it out, and I want you to do an 8-hour stream where you go through and calculate the checksum by hand. And now that I say that out loud, I actually take that back. I don't want you to do that because I'm afraid that you might do that because you made an 8-hour stream where you read the bash manual. I gotta hand it to you. That blew my mind. That's some dedication. Okay, we're gonna do this. If I modulo 100 equals 0, then trying to move that. That's what we will do. Free content. Yo, that's the truth. Is 100 too high? Does it take too long to read 100 of them? Is it doing anything? It's the real question. How slow is this? Okay. Okay. Okay, I'm gonna stop this right now. I'm so scared of how long this is gonna take. Why? If I'm modulating it down by 100, why did it print with a 200 difference between the two numbers? Where did that happen? Yeah, I'm making sure I do local I in every place so nothing else can mess with it. Because that is crazy. Maybe it didn't try to move that one. No, it should try. Like, this should just print. Like, this loop should just print. This is just a real basic I start a big number, I greater than or equals 0, I minus minus. So, like, I don't even know how you would skip this. Like, I actually don't even understand how you would skip this. Why is it counting down by 2? Why is it counting down by 2? I plus 1. That's fine. That doesn't change I. None of these operations change I. Let's look at all my functions. This one doesn't reference I. This one has local I. And this one has local I. So none of these functions can even change I. This one's still local. Still local. We use I here, but that's in a throwaway thing. Oh, wait. Am I doing something crazy here? What am I doing? Oh, I'm stupid. Trying to move file names of I. Right. It's okay. We're counting down the file names. Is that okay? I don't think that's okay. Yeah, the file name should still be everyone. Yeah, wait, what? What? Echo I. I'm doing it right here. I need to print the file names and just exit. Unless it's this logic that I've gotten wrong somehow. Wouldn't be surprised. Okay, those are the file names that we've gotten. So we've read all the file names in properly. Why are we getting every other? So the way the character data is when you read in, the way that the example input is stored, it's the block size and then free size. Block size, free size. So this loop, what this does is it checks if it's even or odd. And then for the index that we're going to use, we divide it by 2. So for character 0, we can extract the file name, what the file size is, and then for character 1, we can tell you what the free block is. But we still store that free block at index 0. So we're just kind of chopping it down a little bit. Like if we're on character 10,000, then divide that by 2, and we're actually at the 5,000 block 5,000. Unless I've gotten this horribly wrong, this should be fine. But I mean, that's a big should be, right? Yeah, it looks right for the example. Yeah, that's why it's like confusing. That looks right. Now, what if we do this on like the second iteration? I don't even know how to do that. Let's just do this iteration. Okay, that looks right still. It's not counting down by 2s. Am I crazy? Yeah, what? This is off. But the other things are in there. Let's not sort it. Okay, that's wrong. Nine nine eight, 996, 994, 992, 991, 990, 989. It's like the last couple ones are wrong. Like, it's just like the last couple ones are wrong. Oh, it's probably the last X that I've processed. Because I recreate those arrays. Yeah, it's because we're doing this stupid next file dance. It's like a sparse array, but it doesn't know how to handle it. I don't think so. No, let me think. Let me think. I think there is something wrong. I think I'm doing something wrong. I don't think this is right. I can't explain why. When is it going to ever try and move the other ones? I don't know, dude. I have no ideas. I think it's because, let me think about this. No, we move something from the right all the way to the left. And then we recreate all the arrays, so the thing at the rightmost thing. Oh my god, no, I think this is wrong, and I think it actually has to be slower. I think it has to be slower. Because what I'm doing is I'm doing a minus minus, so I'm checking the next thing, but that next thing is actually two next things. Because if I move something from the right to the left, I have to recheck the last most right thing because it will be different this time. Why did this work on the example? Yeah, look at this. We never tried to move the 8. We never tried to move the 6s. We didn't try to move them. Yeah, this is a big oops. So if we try if we have to recreate all the arrays, then we have to try again. And the way we try again is by undoing what we did. We just got lucky. Yeah, we did. We totally did. It needs to be like this. So it needs to be 2 times slower. Yeah, it still gives the right output. We got lucky. We got lucky. We got lucky. Oh, that sucks. That sucks so bad. Are you kidding me? That blows. Oh, Christ. All right. This blows. All right. This sucks. Okay. Blazingly fast. Yeah, my ass. Oh, it's going to take 8 years. Is there any way to make this faster before I just let this go run? Have you tried having a faster computer? I mean, I got the Mac M1 Ultra, right? Like, what's faster than that? Probably a bunch of other stuff. Real input. Okay. Okay, we only have to do 10,000 things, right? How's everyone doing? Oh, no. Not again. Hi, I'm so-and-so from whatever recruiting. We're hiring for a merchandise reviewer with flexible hours and pay ranging from blah, blah, blah. Age requirements, 25 to 85. It's going to be tough. I don't know if I fall in that range. Reply yes if you qualify. I would like to receive more details. Thank you so much. The shared vars make this impossible to share across threads. Yeah, I'd have to think about how you would even multi-thread this. Like what would... Because in order to try the next one, you have to, like, see where the next one is. That made no sense. Yeah, I don't even know how you would multi-thread this or make it go faster. I know you make it go faster. You write it in Rust. Now pipe it into a progress bar. Yeah, agreed. Yeah, awesome. You found my channel, man. Hopefully I've been streaming for 5 hours. Oh my God. What is my life? We're 5% of the way there. 5% of the way there. Oh, you're subscribing? Thank you. Appreciate that. It sounds like a joke, but like, appreciate it. Also, yeah, if you're watching my stream right now and you are not subscribed, shame on you and shame on your family. No, I'm just kidding. But if you want to hit that subscribe button, that's really cool because I like looking at that number go up. It makes me super happy. Actually, let me check something real quick. Turn off my terminal. Go over here. Yeah, 2 people paid money for chats. You guys are crazy. That's amazing. I made $7 off today's chat, dude. I'm balling. It's absurd, bro. $7. It's insane. It's amazing. 1,000 gigahertz machine on this? Yo, I wish. Hey, look, we're almost at 10%. That's a good idea. I can look at yours. Do you have it in a like a repo somewhere, or is it just on your YouTube channel? Because I know I've watched your videos, but I don't actually know. I'm assuming you put the code somewhere, but I never actually looked for the code. I just watched the videos, and usually that's good enough. I'm gonna race in case anyone's wondering what's going on. This thing's counting down. I'm gonna go over here and race it, see if I can get it faster in Rust over here. So struct file page. Each file will have a name, which is a number, a U32. We're going to make them all U32s. A size, which is a U32. I could just make it a U size. I don't care. Size, free blocks, free after. This is how many blocks after it are free. And then what do we have? We have the name, the size, the free after, and that's it. And we will have a vec of those. Trying to think. All right, now we're going to go through here and we're going to make a page equals file page. File pages take three things. They take the name, which is the index. They take the size, which is the size or the block. And they take the free after, which is F, I think, right? Oh my God, yeah, they're all characters. How do you turn a character to a number? I think I can do this. What does that return? Is it a result? Let me fix other methods first. Method not found in char. How do you turn a char into a char to number rust? I actually don't know how to do that. You've got to be kidding me. Someone just parses it at ASCII and then just... Oh my God, that's crazy if that's how they've done it. That's upsetting. As you 32 minus 48. Yo, that sucks. Expected U32 found U size. Which one yelled at me? Size. There we go. How are we doing over here? Oh my God, we're almost halfway done. Ooh, and it's going faster now. Or... It's going in some order. I don't know. I'm scared. I can't look at it. I guess it should get faster as it goes on. Cool. So now that we have this, pages.push page, let pages equal vec, mut because it's mutable, and then we will print line. Can't keep going back and forth between languages. What are my errors? Oh, it worked. The len 9, but the index is 9. Oh, free 9 is going to break. Russ is so picky. Okay, here are our file pages. Cool. 0 has size 2 with 3 free after. Ooh, wow, that thing's cranking over there. Cool. Now we have to figure out if pages can be moved. So, start at the end of the list. Want move page. Call it try page. And we need to get the page at the end of it. So how do we do this? We can do a loop for, I guess we should just copy the same logic we had here. I dot dot equals 0 in is this failed syntax? I don't think that's failed syntax, is it? I might just be making stuff up. Oh. I don't actually know how to do this in Rust, I'm going to be totally honest. Whoa. 19 minutes later, we have the bash solution. That ending can't be right. What is this? Right. It's not right. It's not right. It's not right. It's not right because I did the same thing I did in part 1. I just tried to put the big numbers. Well, I just tried to write the big numbers there. Like, I just put a button. Hold on. Ah, I suck. I put that into final.txt. cp final.txt final.safe. There we go. Yeah, I used... So zeros are fine. 1s and 2s and 3s. But once I get to like 11, 12 multi-digit things, that's just going to break. That just... Oh, man. I already made this mistake once. How am I making this mistake again? Probably because I've been streaming for like 6 hours. I might just have to call it a night. I think my brain is just completely fried. I'll probably come back and look at this with fresh eyes. But yeah, that's what happened. I just tried to write them all out. Like I just tried to. It was when it was just the call to print all. It was just the call to print all that did it. It's because of the way I was printing them. That's it. I had the data. I just needed to print it differently. Instead of printing all, I should have just calculated the sum. I had the data. Oh, that's frustrating. Like I should have just taken this and calculated the checksum. So like, loop over this. I have the name, the size, and how much they have free. So like, name times size. I could have just did that. Instead of printing it all. That ending was still wrong though. It's all one thing. You don't think 4867 should have been at the end of the string? I have no idea if it should have been or not. Whoops. The max it can be is 9 times. You're right. You're right. You're right. You're right. That's a really good point. Thank you. Oh, what am I in? I'm in part 1. Yeah, I did. Thank you. I just made a nice little array there. Or this probably executes faster. 137? Yeah, even that's wrong. Like, that's just wrong. Like, I have the data represented correctly, but something that I'm doing is wrong. Oh! I'm not counting the free space. That's what I'm doing in the checksum. Like, if the... Yeah, I have to do some different math for this. I have to figure out the total index. Yeah, like I'll just use like a J or something. I have to do this, and then like for every single operation, I have to say like total equals 0. This is for every single letter that pulls in there. We need to do a accumulator plus equal the index of this spot. This is insane. Just trust. This is for the size of it. We have to do it against the name. And for the free space in it, we do nothing. But we have to bump the index. It should be 2858. Oh, plus equal name times its index in the thing. Yeah, that. 2858. Okay. The checksumming works properly. And then you said something about the final.save. The ending. 4867. Yeah, you're right. That probably shouldn't show up that many times, huh? I can't. All right. What are we at? We're almost at 6 hours. I can't do this anymore. I'm done. Brain's fried. I'm done. I'm checking out for the day. I'm going to call it quits here. We're so close on the bash solution. I will finish it. And I probably will do the Rust solution for good measure. I'll do it on stream. Not going to make you guys like have to sweat this one out. Welcome back, everyone. It is a new day, and I am re-energized to tackle day 9, part 2. I streamed for almost 6 hours yesterday. We got part 1 done, and we could not get part 2 done. I kept running into stupid issues. I kept getting frustrated, and after a couple hours of just continuous coding, I was like, all right, brain's fried, can't do this. Here is what happened in between then and now, though. I jumped off, played some video games, did some late night cardio, and watched some TV. Everything was good. I was chilling, and then I was about to go to bed. It was like 1 a.m., and I was like, nope, I'm still frustrated about this problem. I want to get it, so I took out my laptop, and I started working on the Rust implementation. I didn't touch the bash code. I was like, okay, I know I can do this in Rust. I know exactly what the algorithm looks like. I don't know why I just don't finish this. I promise you, 10 minutes later, I had a working prototype. It just worked. Like, it literally just worked because I knew it would. I ran it against the example input. It looked like it gave the right answer. I ran it against the real input. It gave me an answer. I did not test it. I did not submit it, so it still could be wrong. But I'm going to go over what I did between then and now. So, in day 9, we have this Rust directory that I started, and I did make some changes to the code, and I will show the code changes. So we have this file page struct. The idea is that for each block, we will make a file page. It will have the name of the block. This is the original index before things are moved. The size of the block, this is how much space it itself takes up, and the free after. This is how much free space it has after itself. So we have a vec of these, or a list of these, and that's how we can create all of the possible blocks on the disk. We have this helper function to print the pages. This just goes through and prints them the same way that the example page does. and we have a generate checksum method. So this just loops over all of the pages after we've sorted them and does all the work to generate the checksum. This is code we had working before, so there's nothing new here. We have the bash version, we have the awk version. They all work as expected. The new stuff is down here. So we loop over the inputs. We keep track of all the blocks we saw and all the free spaces we saw. And then we use those. We loop over both those at the same time to create a file page. And the file page, again, just has its name, size, and how much space comes after it. So now that we have the file page, this is no different than how we were doing in bash. We have two loops. We start from the end of the list. So we start at the right side of the list, which is all the way to the right. We have a loop here where we do while I is greater than 0. So we loop all the way to the beginning, but we don't actually touch the beginning because we're not going to move the pieces that are at the beginning of the list. And we name this loop. This is very important because we're going to break out of the loop or we're going to continue back to this loop. But let's move on. We print the pages for our own sake. We'll probably take this out when it comes time to do the real data. And then we figure out, okay, now that we have the piece that we're trying to move, I is the block that we're going to try and move. We start from the beginning. We go all the way up until the piece before I, and we check to see if that's a place that we can move I. So I is what we're moving, and J is where we're possibly moving it to. The way we determine this is we check, okay, J is where we want to move it to. How much free space does it have after it? Does J have enough room to squeeze I in? If it does not have enough room, we try again. We just continue the loop. But if we go here, then we do have enough room. So what I did last night is I wrote down the algorithm in like steps, and then I just implemented those steps. So imagine we have this. We have A, B, C is the place that we want to try and move it, and G is the piece that we're moving. So in this case, G is what we want to move to be in front of C. In order to do this algorithm, we have to remove G from the list, increase F free after by G point size and G plus free after. So what does that mean? F is the one that comes before G. This is the one that knew how much free space it had after. Now that we're removing G, we just inherited a bunch of free space. We have the whole length of G that's free and all the free space after G. So we have to increase F's free space by these two. Now we set the amount that comes after G to be what C had after it minus G's size. It's a little bit confusing, but G is going to move to be in front of C. So now C has less free space in front of it. In fact, C has 0 free space in front of it. G has whatever C had minus its original size, and that's what these two steps here do. And the final thing we do is we reinsert G into the array in front of C at the C plus 1 location. So I just do these steps here, and I literally broke them apart into all 5 steps. So first things first, we remove G. That's what we do. Then we increase F's free after by G dot size and G plus free after. It's so simple. Then we, what do? We set the G free after to C free after. See, at this point, I shut my brain off and I just implemented what I wrote. I trusted my steps up here and I just implemented them. And now that we were able to successfully move it, we continue to main. So we go back up to the main method. We didn't increment I, so we're going to keep trying to move something at the ith location because we moved that one piece out of it. So we made sure not to decrement I. But if we failed, if we didn't match anything, if we weren't able to move the block, try the next one to the left. And the way we do that is we just decrement I. That's all we do. And then we print the final page, we generate the checksum, we print the checksum. That's it. It's so easy. So let's go ahead and comment out, or actually no, let's leave those in. We will do a cargo run, and the input will be the example input. And there we go. Now this looks good because if we go here, here's what it should look like. Now there has filtered out moves that haven't made any difference, but their final string looks like this, 09211743. And if we look at the terminal, 09211743. Like it's the same. We generate the same final string and we get the checksum of 2858. And of course, we go here and the checksum is 2858. Perfect. So let's go through and run this code against our real input. It's going to print a lot of stuff. So let's go ahead and just not have it print those pages. So it'll print nothing. It'll just print the checksum. And we'll run against the real input. It'll warn because that's unused. Cool. Now we have this big giant checksum. And this is where I got last night, and I haven't tested it because I want to save it for stream. So we will see. And that's still not the right answer. Cool. So all that work last night and I still don't have the right answer. But that's fun. We get to work on it now. Here's the interesting thing. That answer is higher than it should be. Whereas before, our answer was lower than it should be. So we're doing something. Something's happening, but something's not happening correctly. So we're going to figure out why that's happening. So I'm at a little bit of a loss. I think our checksum logic is fine. It's got to be just our moving logic. We generated the correct checksum for the example input. So I think what we need to do is when we print the page, where's our print page function? Print page. We print the name, and the page name can have multiple digits. So let's put parentheses around it. And let's go ahead and print the final page. This is going to be a lot of data, but we're going to go ahead and print the final page. And this is what it looks like after we've compacted it. Oh boy. Cool. This is a nice way of seeing it. There's got to be a different way to visualize this. Let's come up with a different way of visualizing this. When we print it, we should print... I guess we could just print each block, couldn't we? Yeah, for page and page. We could literally just, instead of doing this, we could do this. We could just print page name colon size whatever. Yeah, page name size that free that. Okay, so now we can just do page.name page.size page.free after. I'll just make that a print line, and then we'll get rid of that. Cool, so this is what we end up with. This looks pretty compacted. Like, page 0 is here, page 999 made it all the way up here with a size of 3, and there's none of these have any free space after them. And as we get lower, we should have more things that have free space after them. Yep, okay, we're starting to see some free space ones and bigger free space. Yeah. Oh. We are doing something wrong. We could have like an off by 1 type of error somewhere. If we did, that'd be great because it would just be a small fix. There we go. So if that's the case, it should be just a small fix, and we might be able to do something. Let me think about this. While I is greater than 0, because we're not going to try and move the 0th piece. There'd be no reason to do that. We're going to try and move j to I minus 1. So if I is spot 5, we're going to try and move it to 4. This will only do 3. Let's just try this. I might just have an off by 1 error. Please just be that. It'd be awesome. I don't know if that's the same number or not. Let's go ahead and try this. We were off by 1. We just had an off by 1 error. We weren't trying all the possible places. We got the right answer. Wow. Okay. Didn't take long to get the right answer here. All I needed was to take a break and come back for a new day. There's a life lesson in there somewhere. So we know the algorithm works. I had the right algorithm from the beginning. We just didn't have it expressed correctly in both Rust and Bash. Now that we are here, we're not done. We're going to go back and we're going to make this work in Bash. Like, we're not done. Like, yes, we have it working in Rust. So we can do git diff. Yeah, that's good enough. Works for me, lol. Oh, I'm not even sharing this. Yep. So we'll go ahead, we'll commit that, push that code up. Now that we have the Rust working one, we can go back and we can rewrite the Bash working one. And the way we do that is by opening both at the same time and just aligning them. Yo, what's up, Derek? Yeah, that's my goal. We got the Rust one working. We got the points. That's great. I got the points, so the puzzle's done. But for my own edification, I don't know what the right word is. For my own sake, I want to get the Bash one working, so we're going to do that. And how are we going to do that? Well, we're going to take a look at some of these algorithms that we have. While I is greater than 0. Oh boy, we were doing so much in the Bash one. This is crazy what we ended up coming up with. There are so many different ways to do this. We don't even want this. I equals len minus 1, I greater than equal to 0, I minus minus. Okay, this is the same thing. So we're doing the same thing here. Cool. And then for j equals 0, j less than I, j plus plus. I think that's what we have here. 0 dot dot I. So that'll bring us up to less than I. It won't actually give us exactly I. Cool. Now we have to check if cur size is less than or equal to free space. Oh yeah, we have this whole thing indented by 1. Let's do it differently. If the free space is less than cur size, so free space is less than cur size, we know that we're not big enough. So we have to just break on there. So we do a nice little early return type of thing. So now we can downgrade this. Down indent it. All right. So now we can move. Let's go ahead and get that algorithm pulled over from the Rust code. This is the algorithm from the Rust code. Wow, that's not indented correctly. Cool. Let's just X out of that. Yeah, that's good enough. Okay. We have to remove G, but that doesn't quite work in Bash. Because the way we remove G is just by updating pointers. So we have to, oh boy, this is going to be difficult. Increase F free after by, so F equals what came before G. And G in this case is the thing that we are trying to move. So that is referenced by I. So F equals free blocks. Actually, let's just make our lives easier. G equals I. J equals C equals J. So now we have the variables that line up there. F equals G minus 1. Okay, so now we have variables we can reference there. We're getting close. F free is free blocks at F. And we are going to increase that. Okay, now we're going to increase this one. Free blocks at F plus equal C free after minus G minus I. So C free after equals free blocks C. G size equals file size G. The nice thing is if we use these variables correctly, we don't really have to think. We just implement the algorithm. C minus free after minus G size. And there we go. Set G free after to C free after minus G size. Okay. So set G free after, set, so an equal sign, to C free after minus G size. Right, that makes sense. Set C free, I wrote fatter. C free after to 0. Cool. And then reinsert that G to that location. All right. So now we have to remove G, but we don't actually have to remove it. We just need to modify some pointers. So the next file of C will point to G, and the next file of G will point to D. And D is C plus 1. Yeah. It's confusing, but I think we have it. I think we have it. And now when we increment I, we need to break out and try the whole thing again. I haven't tested any of this, but we're gonna see. Well, that's wrong, because that should be 2858. Okay. Why is it trying to move 0? Oh my god, what is happening? What is happening? I have I greater than or equal to 0. Is that what I had in the Rust solution? I don't think I did. I had just greater than 0. Yeah, I don't think it'll make a difference, but we should make them exactly the same. Yeah, it wouldn't make a difference. Okay. Now we break out of that, we get down here, we go back up here, and we have I plus pluses, so we just try again. All right, can't move I to J. Echo can move I to J. Okay. We can move 9 to 0. That makes sense, so we do it. Trying to move 9 to 8. We can't. Oh, we're trying to move 9, which has the name 8, right? The last space of the array is name 8. Trying to move it to 0, can't. 1, can't. We literally can't move it anywhere, which makes sense. Now, this one we can move. We can move spot 8, which is 7s, to spot 2, which is after 1. That's correct. Maybe we just need a little final print all here. Okay, well that is incorrect. Something isn't quite being moved how we expect it to, but that's okay. G is set to I. That's the thing we're trying to move. C is set to J. That's the thing we currently have. F is set to 1 below G. C free after is whatever free blocks has for C. G size is the file size of G. Okay, yeah, this all makes sense. And so number 2 is we set free after. Trying to make sure we're using the right variable everywhere. We are. Okay. So the first thing we're doing is the C free after is set to free block C. The G size, yeah, these are all right, is the file size of G. Echo C free after equals C free after G size. G size. C free after is how much free space it had, which is 3, and the size of the thing we're trying to move is 2. This is correct. This had 3 space after it, and it was moving size 3. Yeah, that makes sense. Well, let's throw some more debugging in. Yeah. Well, that doesn't make sense, does it? How did we end up with this? Somehow we lost track of the 8s and we kept track of the 7s. How do we do that? Just making sure all the variables we use on here are declared local. Total is not. But I don't think we use it anywhere. Man, this is some of the ugliest code I've ever written. But we're onto something. It's when we try to move the 7s that break. We can move this to here. And we go through the process of moving it, but in that process of moving it, we've moved so many other things that we shouldn't have. So something got messed up here. Some of these indexes are just incorrect. Can move 7 to 7. Yeah, see, that's incorrect. It's correct that we can move it to the second thing, but that shouldn't be 7. That should be 8. So something's not being copied over. It could be this recreate all arrays logic. I'm not quite sure. But something about the file names are not working as intended. Maybe it's my recreate all arrays function. Let's print the array there. So here are our file names. This makes sense. Here are our file names. 7 is duplicated. There's our problem. You used file names I in both cases when echo. Oh, did I? Oh man, it's totally possible that I did. Oh, you're totally right. Yep, I'm totally debugging something that's just fake. That's annoying. Thank you. I do still see something weird when I'm printing the array, though. I wonder if something wrong led me down the right path, but we shall see. Yeah, you're right. Can move spot 8, which is value number 7, to spot 2, which is value number 1. That is correct. And then 09123, 09123, and then after it should be 091723. And this last one becomes a 7 after the reconstruction of it when it should be an 8. Somehow this is becoming a 7 here when it should be an 8. 2, 3, 4, 5, 6, 7, and above here is 2, 3, 4, 5, 6, 7, 8. But we're not losing anything. Yeah, so in the reconstructing of all the arrays, something is not quite working. There's probably a pointer that I just haven't updated that needs to be moved. Let me think about this logic. In order to update the pointers, C is the thing that will now point to G, which means G now points to D. Oh, but that means F doesn't point to where G used to point to. Yeah, we need to do that first. We need F to point to H now in this example. So H in this example is just where G used to point to before it was set. I think that's okay. Because we're not using a vec which has indices like indices which Rust has. Okay, well we get a different answer now, but still wrong. This looks better. 0917234568. That looks better. That is how it should be. There should be 2 dots after the 8. Yeah, we updated to the however much we used to have free minus the... Wait, should it be minus? Oh, no, it shouldn't be minus. It shouldn't be minus. My actual documentation above says plus, and it should be plus. Yeah, that's what's happening here, of course. Well, we're still wrong. Well, we move the 7s into the right spot. That's clearly incorrect. Let's use this notation just so we can cut down on the number of errors. If we do it all in math, then it's kind of easier to read this way. Three, 1, 6, 7 just from doing that? Well, that's a little bit scary. Okay, this looks right. There's just extra free space that's not being... Every spot of free space has like 1 extra 1. So some free space looks like it might be off by 1. Increase free after of F by G size plus G free after. 2858. Oh my god, that's it. I just needed to actually read my own instructions. Okay, that's the correct checksum. Okay, wow. Let's go ahead and comment out some of this printing. This might just work. This might just work. So much commented out code. Yeah, let's not jinx it. You're right. How much will this print? Oh, that's so much. Yeah, for this bash solution, like, this is a lot of work. Like, Rust can do this in like half a second, but bash is going to take some time because it's doing so much. I wonder if we can speed up some things. Yeah, I bet recreating all the arrays is stupidly slow, if I had to guess. Yeah, so much of it's just there, isn't it? Reconstructing the next file array. And all we're doing, let me think about this. All we're doing is resetting the next file to just be all of the numbers that come after it. I could probably optimize this. Let me think about how to optimize this. Because if the next file doesn't have anything set, we can just assume it's index plus 1. I think we can safely do that. We can do this. J equals I plus 1. Yeah, and if that's not set, then we can do J. I think we can do this. Or not, we just go into an infinite loop. No, we can't do that. Nah, we definitely can't do that. Because there's other logic that requires looking at the existing pointer. There's too much relying on certain pointers to be in certain places. It's just the construction of this. We need basically a list of every possible number. I'm going to do some testing. I think, can I do this instead as an array? Oh my god, I think you can. Yeah. Yeah, I can just do this. Do I have to fork out to sequence to do this? I might have to fork out to sequence to do this. No, I can be really gross. I can definitely be really gross about this. I can do this. And store that in an array, but then I still have the problem of these numbers. Maybe I'll just use the sequence command. I might just use the sequence command. We're in the 11th hour, so anything goes. So we can do next file equals this, which is sequence of 1 to len. If I do 1 to 5, I actually get 5. Okay, cool. 1 and including 5. I think this works, and this probably should work a lot faster. Yeah, that works a lot fast. Well, I don't know if it's a lot faster. I don't know how much faster that is to fork out to that, but let's see. Anecdotally, it seems a little faster, right? That J shouldn't mess up the other loop. I think I've made all the other things local where they are needed. Yeah, I think so. I think we just have to let this run. So what's it doing? It's looping the last spot of the array. Oh, so it's actually moving them every time. So the last spot of the array is always going to be 999, but the name of it's going to be different because that just means we were successfully able to defragment these things. Or successfully or not successfully. This just means that we've processed it. We may or may not have moved them. So technically speaking, this should get faster as it gets more done because there's just less places to check. Let me think about this. It'll get slower towards the middle and then way faster towards the end. We're going to let this run. We already have the solution working in Rust. We already got the puzzle complete. This is our answer. But now we're going to see if Bash can give us that exact same number. That is stupid. I'm going to take a quick, couple minute break. Go grab something to drink or whatever. But I'm going to let this run. So I guess what I can do is I can let that run on a different thing. Oh, this is way smaller text. This is probably unreadable on YouTube, isn't it? Yeah, that's way smaller. I won't subject you guys to this. I'm just kind of curious. It's weird that you got different answers for Rust and Bash. Well, the Rust answer was correct. So all that means is I'm getting the wrong answers with Bash. That's literally all it means. Yeah, we always start this at spot J, and there's no reason to check spot J if free is 0. Like if there's no free space here, then we can increment the number that we start this at. Yeah, no, Rust gave me the right answer. Rust, I absolutely got the right answer. I did it earlier in the stream, but you can see that the puzzle answer was this. Both parts of this puzzle are complete. I got 2 gold stars for it. So the Rust gave me the answer, and it gave me the answer in less than a second, with no multi-threading or anything. I mean, it's compiled language, just so much faster. But yeah, I'm trying to think. Like if I check J equals 0 and there's no free space there, I should increment where we start there. CP part 2 to new, vim new. start j equals 0 for j equals start j. If j equal start j plus 1 and free space equals 0, then start j plus plus. I think that's literally it. Yeah, I mean, that read in from the example. I should let this run because it's halfway, but I should start up a new one and just get an idea of how much faster this is, if it's faster. This is one of those things that as it goes, it should get faster and faster. It seems like this one's already moving faster. It does seem faster, you're right. I know the text is smaller. If I try to make it bigger, it gets all out of whack. I gotta figure that out. But I think you're right. Like, this one's like tick 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 tick. This is super scientific over here. Yeah, this one seems like it's just faster. How are my cores looking? Nah, I mean, they're fine. They're both maxing out their individual CPU. Assuming my logic's written right, all I'm basically saying is instead of starting from all the way to the left to try and find free space, we can keep moving that pointer further right when we know there's no free space there. Like, hey, we've already compacted this. We can't do it anymore, so don't even bother looking there. That's what that logic does, and we will race them, and we will see which one finishes. Okay. I see some moving a little bit faster here. They're probably finding places they can jump in there early. I should have printed the start J. I didn't even think about that. Yo, what's up, Gorv? How you doing? Oh yeah, look at this. The names are starting to get interspersed. That's cool to see. Yeah, we're moving down now. Wow, we're actually making progress in the loop. About halfway in, we're actually starting to make some progress. Look at that. Speeding up. Wow, how incredible. By contrast, this thing's still moving a little bit slowly. Although I think this one could pick up in the end. So we'll see. How about you? I'm hanging in there. I'm good. I streamed for about 6 hours yesterday and couldn't get the solution to part 2 of this problem, and it was very frustrating. But then I jumped back on today. I got frustrated at 1 a.m. and went through and figured it out in Rust and got a somewhat working implementation in like 10 minutes. It's way easier to do this in Rust. And I ended up solving this puzzle. So this puzzle is solved. It's complete. I did it in Rust. I have the right answer. I know the algorithm. I'm just trying to make sure I can get it working in Bash now. Okay, it's already down to 9,000. This thing's cranking away. Look at that. Definitely speeding up now, which is good. That's what I thought would happen. And that's because now that it's going, the pointer on the right-hand side is getting smaller, so it has less things to check, so it should get faster and faster. This one should get way faster because it'll have less things to check on the left and the right, but we have to let it get there because this one's going to start cooking it. This looks like the kind of output you'd have on a TV when like there's like a scene where someone's hacking on a computer. Like, this is the kind of output you would see. Oh yeah, there's no way the one on the right's catching up. I'm going to let it run and we'll see how fast it can go, but yeah, it's not catching up. Now, this thing totally could just spit out the wrong answer, so I'm mentally prepared for that. Moment of truth. 6286787. 6287331. No, it's wrong. 6287. This one is slightly higher. Yeah. The checksum here is just slightly higher. So we just slightly got the wrong answer. That's okay. We tried. We'll let this one over here finish. Oh yeah, there's no way it's catching up. I am back at it. I have it working in Rust. I got the right answer. So I do know what the right answer is in Rust, which is fine. Now I'm stubborn. I'm just absolutely stubborn, and I want this bash one to work, even though the code is so garbage. Honestly, I should rewrite it. Truly, honestly, I should rewrite this code. Yeah. Calculate the checksum with all just in case. I could do something like that. It shouldn't be overflow. I mean, this number should fit comfortably in a 64-bit number, and Bash can do 64-bit numbers. And it looks so similar to what the right answer is. Like, it literally is so close to the right answer. Here's what I'll do. We'll take, this is the answer I got. And the right answer I'll grab from the website, copy and paste from the website, and we'll get the difference between them. That's not that big of a difference for how long this number is. Being off by that much when the number is here. Like, they're very similar, as you can see. How long does it take to run in Rust? You ready for this? Are you ready for this? You're not ready for this. You're absolutely not ready for this. Cargo run, dash Q. Oh, we'll do release. Example input. There we go. Now we'll do the real input. It might print a lot. Let me get rid of the prints, just because the prints will slow it down. Yeah, this is the only thing. I don't want to slow it down with the prints, so it'll just print the checksum. Here's what we'll do. We will time it on the real input. Actually, no, this is an unfair... Let's do it correctly. Cargo build release. We'll build the release binary, and then we can run the release binary directly. And this way there's no compilation steps. Like, this will just be the raw program running. Real input. Time it. That's how long the Rust version takes. 0.04 seconds. It takes 41 milliseconds. And probably a lot of that is actually like fork and exec. So that's the Rust version. I mean, like, what do I say, man? That's the Rust version, and it gives the right answer. So, like, oh, man. Here's the thing. I like these puzzles, and I'm having a ton of fun with them, and I'm going to keep trying to do them as long as I can in Bash. But if it ends up becoming too difficult, I still want to get the puzzles done, so I probably will switch to just using Rust. I'm comfortable in the language. We have, you know, better structured data. Because the Rust code even just looks nicer. Like, I was able to make a file page struct that keeps track of the name of the file, the size of it, and how much free space it has after. And then when you have that information, it's super easy to just write, you know, very C-style looking code to generate the checksum. And it's very easy to write code, like, to write this algorithm out with a list and then just do each step of the algorithm. Like, Rust is just great. Yeah, structured data is like what I need. Like, it's just the right way to do it. Ah, man, but it does stink that this just doesn't seem to be right. There's some logic here that is just incorrect, and I just don't know what it is. So it's unfortunate. I like Rust. I would recommend Rust if you're between Rust and Go. I'm a little biased. I mean, I just love Rust, so there's that. Where do I use iFreeSpace? I don't use iFreeSpace. Where do I use current size? That's the current size of the thing we're moving, and that's how much free space we had available. Cool. We start at the beginning. We go all the way up until the thing we're trying to move, and then we see if the free space is less than the current size, we don't have enough to move, so we just try again. If we can move it, then we have to go through this whole song and dance of moving it. I mean, it could be my logic to generate the checksum that's wrong, but I doubt it. Calculate checksum. Local I, J, accum, len, and total. Okay, so we have the length of everything. We loop over every single element in that array. We get the name, we get the file size, we get the free blocks. So this is the index. Total. Okay, so total is the index of the thing. Okay. Yep, so it's at spot 0. Then we increment it. Now it's at spot 1. We increment it. Yeah, this all makes sense. And if it's a free space, we just increment the total index. We don't actually do any work. I can't see anything wrong with that logic. Oh, look, it's starting to go a little bit faster on this thing now. That's cool. What other languages would you be able to solve these puzzles in a reasonable time? Rust would be the easiest one. I could do JavaScript, but it'd be hacky JavaScript that looks like someone wrote it 10 years ago, which is me. I'm that someone. I would say Rust, C, JavaScript. After Rust, it'd be C. I would prefer to write it in C. Just looking through my code, make sure I have everything right. Generate checksum. I basically do the exact same process here. Like this is identical. Oh, I could just increment the index by that number instead of doing it in a for loop. It'd probably be a lot faster. But generating the checksum is not the slow part of the code. Okay, look, this one finished over here. So this one finished a lot faster once it got cooking. Yeah, it did. But let me check the number. It gave us the wrong number. Yeah. It's just slightly below what it needs to be. Like that's what's happening here. So it's just slightly below what needs to happen there, which is sad. Let me do this. Let me grab the logic out of new that I did. Okay. Oh, I'm editing new, am I? Yeah, edit part 2. Okay. So this will start moving. Okay, cool. So now start J gets incremented when there's less things for it to check. That's cool. That's a cool little thing. Those kind of problems, Python should be fairly fast if you also account for more easy writing. I don't know Python. So like, I mean, maybe you guys can do it. I don't know Python. Like I wouldn't feel comfortable in that language. I don't know it at all. Can you check the diff after defragmentation between Rust, Bash to debug it? I think that's what I'm going to have to do. I'll have to come up with some sort of way to write down what it looks like. And I think I already have like a format that makes sense. Let me check my Rust one, because I think my Rust one had a good format. What am I doing? Yeah, I think for the format, I print out... Yeah, so at the end, I would print out the page, the size, and the free. So... if I run this, do a cargo run -q, example input. So at the end, it will print, okay, the page with the name of 0 has a size 2 and a free of 0. This is what it looks like after defragmentation. So I could just write that to a file, like output.txt. So much faster than Bash. Oh my god. So yeah, now if we look at this, we can see like what it should look like after everything's done. So with that in place, I can make the Bash version print that exact same output. We can put a print all into final.txt. We'll also just do a print all here. Wait, why don't we just do this? Hey, look at that. Unix. That will do both. It'll print it to the screen and write it to the file. So now we will do a print all. And the way we do a print all is we loop over everything we have, name size free, and we just... I'm basically doing what we did above, but we'll just echo the exact same output. So page number colon size free. Is this the output? No comma. Close, but no comma. Cool. Then we don't need this. Okay. So this just generates the exact same output. Nice. And then the trying to move, we'll just make that go to standard error so we can look at it in the output, but it won't get put there for us. Okay. Cool. So that output should look exactly the same. Yeah, size 2, free 0, 1, revive 2. Cool, 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 cool. You can easily take the Rust output and make the defrag string you have saved and compare the files. That's basically what I'm going to do. I can't make the defrag string that they show in the example, if this is what you're talking about, like here, because this example falls apart once your digits go above 9. I would need some sort of symbol to represent them or put parentheses around them. So that's why I'm just going to print out what the final list looks like, basically the linked list. So yeah, we got part 2 printing that. Nice. So we can time this and we can do real input, and then this should just write to that file, I think, right? Final.txt. Yeah, cool. So yeah. Missing equal sign. Where? Howdy again. Do you prefer Vim or Nano? What do you think? What do you think when you watch my stream? What do you think I prefer? Oh, equal sign in the output. You're right. No, wait, am I? No. No, there's equal signs there. Am I crazy? Yeah, these outputs look the same to me. Actually, we can just find out. Final diff and Rust output. Oh, right. The Rust the Rust output is the full big thing. The Rust output. Okay. There's no equal sign in here. Okay, that's what you were saying. Size free. Okay, I got it. I could have edited it out later, which is not the end of the world, but for the sake of doing things right. Part 2. Read in from example input. Should generate that. When I cat final text, it looks like that. When I cat the Rust part 2 output.txt, I get that. Very similar. Cool. Time part 2. Read in from real input. And that's all we should have to do. And it will just run. And it will take a long time. But that start J will move up. We'll at least get to see that, which is pretty neat. Instead of print pages, we'll just make this as like create serialize pages. And this will return a string. And then we can just do this. Make a mutable string here. And then we can write this into the string. Format this with a new line. And then we can do s.push stir. Line. And then we can just return s here. So now this function generates a string instead. So instead of print pages, we'll just change this to serialize pages. Yeah. done.text, and then we can do, what is it, fs, write the name of the file and the data we want to write to it. Cool. And then we can just do the same up here. Instead of printing them, we will just write them out, and we'll write them out to, we'll just keep a global counter. And then we'll just increment the counter here. So serialize the pages, create a file name for this. The file name will be Rust number. There we go. So now this will write out a whole bunch of text files into the current directory. So let's go ahead and just run this, and we'll run it with the real input, and I will show you guys how fast it is to write out these actual files. You ready for this? It's gonna have to compile, so that might be a little bit of why it's slow. I shouldn't have ran it with the -q. We could have actually seen it like compile. Okay, I'll be honest, I thought it'd be faster than this. Okay, yeah, it's done. I mean, I don't know how long that took. I should have put timing in front of it, probably like a couple seconds. But yeah, there we go. So now if we do rust 0.text, that's what it looked like at first. So we could do a diff rust 0.text to rust 1.text, and this will show us what the first move looked like. So in order to turn rust 0 into rust 2, we'd have to get rid of page 0 having size 5 and free 4. Now page 0 has size 5 but free 0. So now it has 0 free spaces, and the reason for that is because we moved 999 into that spot, and it has a size of 3, and it has a free of 1, because 3 plus 1 equals the original 4 up here. Cool. And because of that, 999 now had to move out of the way, and 998 had its free space increased by whatever the size of 999 was. This all makes sense. This all works. I can do color diff instead. Color diff's just like a little wrapper I wrote around diff that just uses awk to add coloring. Makes it way easier to see. I don't know why I didn't just use that to begin with. We should just break out when that left number collides with that right number. Hey, we did. Cool. Oh, I like how nothing got printed here. That's really cool. Nothing got printed here. I wonder if that's part of the bug. I mean, it shouldn't be. We could just be missing one thing at the end. It took 14 minutes to run. Whoa! Ah, it takes forever. And this is what the final thing looks like. Let me go look into this terminal, and we're going to look at the final thing. I think I called it done.text. Let's go to the bottom of done.text. 5452, size 9, free, 42929. 5452, size 9, free, 42929. 33, 3, 23, 20, 85. What if this is right? All right. This is less than ideal, everyone. This is less than ideal what I'm going to do. But I'm going to do it, and you're going to watch me. You are all complicit in this. What y'all know about copy and paste? Can I just do this? Oh yeah, that's way easier. Oh my god. We're getting there. We're getting here. Yeah, the fact that something is not printed at the bottom. Done.text. Cool. We're gonna let that paste in there. So yeah, okay. So this is our bash version of done. So in order to turn our bash version of done into our Rust version of done, where are we? We're in Rust. Okay. in order to turn our bash version of this, whatever. In order to turn the bash version into the Rust version, the wrong into the right, we would need to do this. Okay. That's the only difference? So when bash is said and done, when Rust is said and done, the only difference is this one line. This one line. And that makes sense. The bash version, look at this. What is this? The bash version lost track of a block. At some point, it lost track of a single block. The block it lost track of was 4867. What happened to 4867? Where is 4867? Oh, it's towards the bottom, but it's not like it's not close to the bottom or close to the top. It's just in its own little world. We have lost track of 4867, a size 9 thing. So now all of our checksum calculations are going to be wrong. Wait, did I say 4867? Did I search for 5867? I searched for 5867. 94. Okay. We've lost track of 6 bytes. We've lost track of them. We have lost them. Where have they gone? When do we attempt to move 4867? I'm guessing that's towards the end of the thing, right? Well, we have the Rust version. The Rust version is very fast. So let's go ahead. And the Rust version even uses the slower algorithm, which is funny. Let's go ahead and print that out. I want to know when it tries to do this. We're not going to write that file out. We're not going to bother serializing it. It's just going to be slow. Okay, when do we try to move 4867? Okay. So now we will. You search 4857. Did I search it wrong a second time? Did I really do that? I probably did. What do I keep saying? 4867? Okay, wow. 4867. 4867. It is 94,000. 4867. Size 2 with free 2. That's where it shows up. And when I go into the bash version, it's just not there. So we need to figure out when does 46, whatever, I don't care. 4867. When does that one? Yeah, 4867, size 2, free 2. When does that one get tried? We'll find out by doing a cargo run of the real input. Okay, try to move it twice. And it's like towards the middle. It's just like some random time in the middle we try to move it. What is special about that one? How are we losing track of it? How do we just lose a variable at some point? Yeah, and somehow when we went to print the bash one, remember, now it's gonna be all messed up now. But yeah, it printed this. So like something broke here. Why did it try to move it twice? I agree. Why did it? Should it? Is that normal? Let me do a test here. I'm gonna run it and pipe it to sort. Then we're gonna pipe it to unique -c and then sort -n. It looks like it tries to move a bunch of them twice. No, I think it's fine to move something twice. I think it's okay to move something twice because this is not the index, this is the name of the block. So you might be able to move the block to the left and then your pointer goes down, 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 down. And then when it encounters it again, it will try to move it again. That's normal. Even the example, I think shows something being, no. Yeah, I think you can try to move it twice. It just shouldn't work. If you've already moved it once, there shouldn't be anywhere else that's valid for it to move. I just don't have a check for that. Like, it will try to move it twice. It just will fail. Dump every index in Rust when it's 4867. Yeah, we really got to do something. Like, what is happening here? It'll be at the best position the first time, but the loop will go down and see it and be like, oh, hey, we should try and move you, but it should fail. There should be nowhere to move it to. I could keep track of which ones I've moved and just ignore them. That's totally a possibility. I mean, that'd be a way to speed up the Rust implementation, and even the Bash one. But, like, I don't do that. So it will try to move it a second time. It's already in the best position. So we just don't keep track of what is in the best position. We could. It might be faster. Let me go ahead and just add that to Bash. Because what we could do here is we could do something like declare -a has moved. And then once we know that we've moved something, we could say, what is the thing we're moving is G. So we can do has moved G, which is the name of the thing that we're moving. We need the name. Equals 1. Let's just do this. Yeah, has moved equals 1. And then we can do a quick little check up here, like, oh no, J is the thing that we're trying to see if it should move to. So the thing we're trying to move is not J, it's I. No. Yeah, once we've moved it, whether we've moved it successfully or not, like, we don't need to keep reprocessing it. So I don't even know if we need to store this here. We need to just say, like, hey, like, once we're processing this, we could basically just store it here, whether we're successful or not. Like, if we're successful, it's in the best position. If we're not successful, it's in the best position, and no position's going to open up for it all of a sudden. I think we can do that. I don't know how much faster that'll be. Can't tell if that's faster or not. Let's go back. Let that run. Let's go back to the Rust implementation. Yeah, because the freed space only appears behind the index we moved. Yeah, exactly. Somehow we are losing 4867. So about 5,300 moves in, we try to move 4867. And we don't try to. I mean, we move it. It moves successfully. Maybe the J index catches up to I. Yeah, it's totally true. We got to dump everything here. If we are at 4867, we need, we just need a full dump of everything. Counter equals this. I equals this. I is equal to 9421. That happens early then. Yeah, that's relatively early that it's 9421 because it starts at 10,000. No. The counter goes up, doesn't it? So about 9,000 moves in, we encounter that. Weird. Oh, it's not Vim highlighting, it's my terminal highlighting it. That's annoying. How's this thing doing? Does seem to be going a little bit faster over here, I will say that. Little optimizations on the bash one are nice. Yeah, something's just being lost in the bash one. All right, so which one did I... Let's do the Rust one. We'll do the Rust one. We'll find the counter equals this. This happens at 5391 and 5390. So, 5390 is where it hasn't happened yet. So if we cat 5390, where are we? Cat Rust 5390, we're here. So what happened between these two steps? So what happened here is we moved 4867. We haven't moved it. We've just moved the free space. Oh, okay. Okay, so what happens here is 4867 and 4866 don't move, or 4867 doesn't move. It just gets pushed against 4866. So there's a gap, a 2-space gap between them, and they just slam together. And then we try to move it again between here and here. And this is where we try to move it again. And nothing was able to be moved because it's already in the best position. Yeah. I'm looking at the example input. There's no... Okay. We're done here. We're going to make a new example input. I know, I think I have an example input that could make this work. Ugh, God. I'm going to write out what I want. I want this. I want that. That's what I want my example input to be. So 22 will just get shoved up against 11, but it won't actually have to swap places with anything. That's what I want. So I need to represent that. And I have to remember how this thing works. So spot 0 will have 2, then there'll be 2 free spaces, then there'll be 2 of this. That's it. That's all I want. Literally 2, 2, 2. So if we do part 2 and read in from new example. Okay. Okay. And if we read in, if we use the Rust example. Okay. This is our problem. We've isolated it. This is the problem. Literally the problem is if the decompressed data looks like this, then we don't actually move. We're not moving 1 over. We're just moving the free space. Rust handles this because I wrote the algorithm beautifully, because I'm a master programmer and there isn't a programmer better than me alive. The Bash one doesn't handle this because Bash is the best programming language that's ever been written, and you will never hear me talk poorly about it. Cool. We have... Oh my god. Thank you everyone for all your suggestions. We have a way of exercising this bad behavior now. So, 137 has a bad... Oh, wait, is it just the has moved part? Oh. Is it just my new logic? If it's just my new logic, then... Oh, no, it's okay. Because that means we're failing to extract the file names. That's okay then. That's okay. Yes, the name is empty there. Why is the name empty there? The length of the array... What is len here? The length of the array is 2. So I equals length minus 1. So I is set to 1. While I is greater than 0, which it is. We're just doing the first iteration of this. I have to figure out what's going on here. Here, when I is set to 1, and that's fun. Trying to move 1 to 1. That's good. Like, we're trying to move it to itself, and there is free space for it. But then we somehow end up here again, when we shouldn't be there, with an I value that's out of place. Huh. Reading data. I is 2. Oh no, the len is 2. Then we're here. So we start at 1. Here again with 1. But this time it's a bad array subscript. Why is it a bad array subscript? You're right, I could do this syntax. It shouldn't matter for an index arrays. Bad array subscript on has moved. Yeah, because somehow name is coming out empty. You know what we'll do? We'll print the array of file names here. Alright, we've lost a file name in the process. Yeah. We've lost a file name in the process. We're not keeping track of it properly. Wow, glad I threw this in. This is exposing some logic that's breaking here. So I'm gonna guess that it's in recreate all arrays. God, I hate this code. I'll be so happy when I'm done with it. Before. Looks like I've already done this logic before. After. Yeah, okay. So it's in that logic that we are removing that. How is that happening? The len is set to 2. The len is set to 2, so we should be adding this in twice. Although this is throwing me off. We should never encounter this problem. This might have been masking a bug. Um, 0 points a null and null points a null. Somehow we're getting null written as... Yeah, that's not right. Null points to null. I don't know what's happening there. Our pointers are wrong. And I think it's because we're trying to do a swap here. Only swap if needed? Ugh. I don't want to complicate this logic too much, but like, if... Let's see. Where's the thing we're trying to move? Yeah. If G minus C is 1, then we know they're right next to each other, so we don't need to move them. So if G minus C is greater than 1, then we need to move them. Well, this looked way better. We got a checksum of 5. What do we get with the Rust implementation? We get a checksum of 5. No way. What do we get? We get the example input. We get 2858. I think this will work. I think this will work. It's a lot of output it prints. Let's go ahead and just clean up some of that output, because I think that's a lot. Yeah. Wow, yeah, we weren't handling that one specific scenario, but we were able to create a test that can simulate that specific scenario. How many times am I just gonna echo here? I like the trying to move. That's useful. We'll leave that in place. Okay. Okay. Wow, so there was just one scenario that wasn't working. I enjoy this live because you suddenly look like a mortal debugging code like the rest of us. I am. Yeah, don't let me fool you, man. I suck at programming too. But it's fun. Debugging code is like fun. Frustrating. Can be incredibly frustrating, but it can be rewarding when you get it. So yeah, I think we just let this run. And that will handle that one scenario that apparently only happens once. How crazy. How absolutely crazy that that is the case. So this, what, takes 10, 15 minutes? All right, I'm going to step away for a bit, probably a minute or two. I'll be back. How long does it take the Rust version to output an answer? 40 milliseconds. Yep, 100%. It's crazy fast. Here, I can show you. I can show you over here. Where are we? Cargo, run. Right, here's what we'll do. We'll build it in... let me do some testing first. Example input looks like that. Trying to move, it prints out all that stuff. And then the real input, we'll print out a whole bunch of trying to moves. That will slow it down, but you get an idea of how fast it is. If I comment out this, and we just print the checksum, or at least those things and the checksum, we can see that it's like crazy fast. If we throw in a dash release, like, forget about it. Like, that's how fast it works. It's so fast. It's stupid. So like I said, if I get frustrated with these puzzles going forward, I'll probably ditch Bash sooner and just go straight to the Rust solution. It's the way to do it. Opinion on PowerShell? I've used it once in my life. I have no real opinion on it. Yeah, I couldn't tell you anything about PowerShell. I know some people who use it and love it. I've tried to convince some people to make you suck at PowerShell. But yeah, no, I don't really have many opinions on it. I don't have to use it much, luckily. Oh man, I wish this thing just, moved a little bit faster. Wow. Wow. That got real fast at the end. I'm going to take the good checksum, and I'm going to put the good checksum here. That is the correct checksum, 62873, 62872. Look at that. It's still wrong. It's still wrong. How is it still wrong? Was it 4687? Was that the one that I was trying to move? Four, 8, 6, 7. Okay. Yeah, that looks right. All right, so now that we are done here and we got the wrong answer, we can do the same thing we did before. Because I don't think I actually... Did I write this out to a file? All right, I teed it to a file, didn't I? Final. Okay. So we can do a color diff final to rust done. So here is what we do. Oh, wow. Wow. We are so close to getting the answer, guys. Here is what we would have to do to make our bash version match our rust version. So bash thinks that 4867 exists, it has a size of 2, and there are 0 free spaces after it. Rust says that it exists, it has a size of 2, and there are 2 free spaces after it. That is the difference here. Bash thinks there are 0 free spaces after it, and Rust thinks there are 2. Boy. We are so close to the answer. Like, so close. It's unbelievable. I think we only need to recreate all the arrays if we move them. That's a speed up right there. Wow, that's crazy. That's crazy. The only difference is the free blocks that come after it. So the first thing we do is we increase the free. Oh. Yeah, let me think about this. I think in this example, F and C might be the same. Yeah, I think F and C are the same, but that's okay. Let me think about this. Because we escape the swap if it's next to the other and didn't update the size. Is there any other instances in the Rust version where free space is not 0 after remove? I don't know. Hold on. Let me think about this. I have to... I can't take in any other information until I understand this myself. We have C, we have G, and we have F. And in this case, F and F, which is the one that comes before G, is the same as C in this case. So F and C are the same. If that's the case, what do we need to do? So F becomes this. So we increment the free size of F to be everything that came after it. Yeah, this needs to only happen. This needs to only happen inside the swap. Like, it's crazy that that's the case, but that needs to happen only inside the swap. Else, don't swap them, just update free space. So in this scenario, we're not going to swap them. We are just going to update their free space. Can we come up with an example that triggers this behavior, maybe? Well, I already rewrote this logic. Actually, yeah. Let me do this. I have my idea, but let me do this. We're going to try and trigger this behavior. We'll do nothing in here. New example is what I called. I need to get better at naming. But I do have move new example to simple example. There we go. This will make my life easier. The simple example is literally 0, 0, dot, dot, 2, 2. Yeah. And it gets me the right answer. Can I get something that fails this example? What would fail it? If I constructed this scenario? Let me think about this. If we had... we would try to move the 2, 2, 2. If I had this example, we would try to move this to the left and it would fail because there's no room. Then we would move on here and try to move it to the left and it would succeed because there is room, but it wouldn't actually swap anything. I think we need that. So my simple example, I think we just change this to a 3. And we get 15. Now if we go into Rust and we cargo run -q, simple, we get 15. Okay, so the bash one works. Why does it work? I want the bash one to break. What can cause it to break? I need to create an example where it frees up space. Let me think about how to do this. One free block here. I think this might work. So we're going to try to move the 44 and it's going to fail. Then we're going to go here and we're going to try and move the 3 and it's going to work. And that's going to free up space for the 44 to go here. I think maybe this works. Two, 0, 1, 3, 4, 2, 0, 1, 1, 1, 1, 2. Whoa. Two, 0 free space. 1, 1, 1, 1, 2. $35, $47. Okay, so we're getting different answers here. Okay. Okay. So at the end of all that, what does the Rust one think? Yeah, the Rust one, there's some free space that's gone missing, which is the exact problem we were seeing before. So I think we've got the bash thing in a situation now where we can detect that situation. This isn't going to work, but it's going to do something. 49. And what does Russ say the thing was? 47. Yep, okay, so somehow it thinks there's still a free space of 1 and 1. That's fine. Don't swap them, just update the free space. So if they're next to each other, so if G was next to C, all of the free space that came after C should get set to 0, and we should add it to G's free space. That's all we need to do. So G's free space, free blocks at G, will get added to whatever free blocks at C was, and free blocks at C will get set to 0. I think that's how we do it. 47. That's the right answer. 2858. That's the right answer. I think that's it. I think that's it. I think that's it. Oh my God. Okay. So this should take another 15 minutes. Oh man. I'm gonna let this run. I'm gonna go grab something to drink, take a little break, maybe like 5 minutes or something. I'll be back. Oh wow, look at that, even faster. What do we have here? That's a big number. I'm gonna grab the correct number from the website and we're gonna paste it in. So as you can see, I grabbed the correct number there. I paste it in the terminal, and moment of truth. 62873, 62873, 17016, 17. It's right. It's right. It's right. We got it. Oh my God, we got it. The bash solution is finally correct. 2 streams, over 8 hours. Advent of Code 2024, Day 9, Part 2, in bash. Done. Done. We do fork out to one external tool, SEQ, for sequencing. I can do it in pure bash, but my God is it slow. So I just use that as a speed up. We're done. We're done. We debugged the shit out of that program now, sent it to oblivion. That's right. That's right. And it feels good. Oh, I put so much time and effort into this. Like, I'm so sick of it, but it feels good. Oh, man. Whew. I feel good. I feel good. I feel invigorated.